morning, ladies and gentlemen. Apologies for the late start. However, we now have forum and we are ready to start. I'd like to take this opportunity to welcome you all to the Vital Voice examination today of Mr. Nicholas Walter NZALA. Thank you very much for making time to be part of this process. I'm called Michael. I'm the Dean School of Physical Sciences and Chair of this committee. Our examination process today will proceed as follows. We shall start with a word of prayer. This will be followed by a record of attendance of the Vital Voice committee. Then I'll introduce the committee to the public, which will be followed by a brief introduction of the candidates' supervisors. We'll then have a brief introduction of the candidate here, who will then be given up to 45 minutes to summarize the work that is completed. We'll then move on to the session of discussion, where we'll start with an introduction of the discussant. We'll then have up to 45 minutes to engage and discuss with the candidate. We'll then move the engagement to the Vital Voice committee, which will then be opened out to the public. The committee will then convene for 10 to 15 minutes, where they will deliberate over the presentation of the candidate here today, which will then be result in a verdict, which will be communicated to the public. So that's the process here today. And without taking any more time, I would like to request the Secretariat to lead us in a word of prayer.
Research findings, for us that you continue to guide us and bless us. And let us be under pressure as we decide on the students' research findings. May we bring glory to your name and to us making of it.
Thank you very much. Blessing in the morning. Now, we have a book for the Vital Voice community. Please let's record our attendance in there. The candidate here today, Mr. NZALA Walter Nicholas, has satisfied the requirements leading to the defense of the cases here today. He has completed all the cross-cutting courses, up to 3 courses indicated successfully. And then he has undertaken a number of up to 7 internal conferences and workshops that support and disseminate the work that he's been undertaking. He's also published 3 papers as part of that requirement of his award. And he's then gone on to write thesis titled Developing Inverse Artificial Neural Network Algorithms for the Retrieval of Meteorological Parameters. This work was ably supervised by Professor Tadeo Senyonga, Dr. Nicolaus Senyonga, and Dr. Dennis Mayimba. So the work was then examined. We had 3 examiners, 1 internal, 1 external examiner, and 2 internal examiners, and they all positively scored the candidate. So the candidate therefore qualifies to defend that piece of work orally here before us today. to briefly introduce the three supervisors of the candidate. I'll start with Professor Tadeo Senyonga, who is from the Department of Physics in Makerere University. Thank you. He holds a BSc of Makerere University. He also holds an MSc, Master of Science in Physics, of the University of Bergen in Norway, and a PhD, Doctor of Philosophy in Physics, of the University of Bergen in Norway as well, and went on to have a postdoctoral fellowship at the same University of Bergen in Norway. His professional and academic activities include, he's done lots of research and publications, he's taught and mentored, continues to do so, several students. He serves the physics department of the university, several community engagement and outreach programs. He's involved in grant proposal writing, professional development. He also collaborates with industry partners and is of service on several academic committees and boards. His associations and awards include being a member of the Uganda Physics Society. He's also a member of the Optica, formerly known as the Optical Society of America, OSA, a member of the International Ozone Commission, WMO, and a member of African Ozone NILU-UV Monitoring Network. His research and professional interests include optics, atmospheric space and computational physics research that include planetary atmosphere and ocean studies, environmental monitoring and modeling, artificial intelligence ANN applications in prediction of weather parameters, space weather and ionospheric research, as well as atmospheric optics. Thank you very much and welcome, Professor Senyonga. Our second supervisor is Dr. Nicolaus Senyonga. He's a Ugandan, born in 1979. Did his UCE, Assembly SS in 96. Holds the SCE certificate from NZALA in 1999. And he has a BSc, Bachelor of Science, from Makerere University of 2003. And he also holds a postgraduate diploma in education from Makerere University, obtained in 2005. And an MSc degree in optics and atomic physics from the University of Bergen, Norway, obtained in 2008, and a PhD in optical physics specialization in marine optics. He's been employed at Makerere University since October 2004, and is currently a senior lecturer. His research interests include light scattering and absorption by particles, energy physics, fluorescence measurements, bio-optical modeling, light conditions and their effect on the life of phytoplankton in freshwater and marine systems, and radiative transfer in carbon systems. Thank you very much and welcome, Dr. Senyonga. Our third supervisor is Dr. Dennis Oyingwa. He's from South Africa since January 7, 1981. And his education background includes Kasao Public Primary School, where he joined, then went on to join Kasao Secondary School for O and A-level education. He then went on to obtain a Bachelor of Science from Makerere University between 2003 and 2006, and an MS in Physics from the University of Bergen, Norway, between 2011 and 2013. And then went on to obtain a PhD in physics from the University of Bergen in Norway between 2013 and 2016. I think we need to thank the University of Bergen for we very much appreciate that. And he then was appointed as a teaching assistant at Makerere University in 2008 and has developed through the ranks the level of lecturer of physics. His main research interests, among others, include atmospheric physics. Thank you very much, Dr. Muniba, and welcome. We'll now move on to our candidate today. And I will start by introducing him. This is Mr. Nicholas Walter NZALA. He is affiliated to Makerere University Business School as well as Camberwell University. Mr. Nicholas Walter NZALA is a holder of the Bachelor of Science in Education degree of Camberwell University, obtained in 2005. He also has a Master of Science in Physics degree of Camberwell University, obtained in 2012. Mr. NZALA is facilitating the learning of computing mathematics, digital electronics, and electronics course units at Makerere University Business School, Department of Computer Science, and Software Engineering, Faculty of Computing and Informatics, since 2022. He facilitated the learning of physics at Camberwell University between 2007 and 2019. He has taught physics and mathematics at A level. Mr. NZALA is a member and affiliated to Uganda Professional Science Teachers Union, UPSTU, Association of Uganda Germany Alumni, that's AUGA, where he is the treasurer, and he is very, very present on the certificates, academia, EDU, and Google Scholar. Mr. NZALA's research involves development of inverse artificial neural network (NNI) algorithms for the retrieval of meteorological parameters based on global horizontal solar radiation measurements. He constructed NNI algorithms that predict sunshine hours, ambient temperature, relative humidity, and rainfall. The threats posed by climate change are real and bound to affect all humans and animals. The high cost of acquiring meteorological equipment and maintaining them has resulted in a severe lack of critical meteorological data in many developing countries, hindering effective weather forecasting. The algorithms constructed will enable acquisition of large data sets of some of the essential meteorological parameters needed in weather prediction, climate change quantification for the various climatological regions of Uganda, where some equipment is lacking or malfunctioned based on solar radiation measurements only. The professional interests of Mr. NZALA lie in one, climate change, prediction and monitoring of meteorological parameters so as to inform and influence interventions. 2, inverse artificial neural networks, the applications in various fields. 3, optical activity application to determine edible oil quality, and lastly 4, diesel fuel, its composition and quality. Thank you very much, Mr. NZALA, and welcome. Now we'll move on to the next stage of this process where Mr. NZALA is going to summarize to us what he has undertaken during the course of the study. Over 45 minutes minutes, please summarize to us why this study has been important. So very, very clearly, the rationale for this study and where the gaps were that the problem arose from, so that we see very, very clear objectives that were spelled out and with the correct methodologies to address them, and move on to give us all the key results and ground that within the known science of the subject, and then give us very, very clear conclusions that derive from your key specifications. Okay? So that's 45 minutes, and if you're ready, please proceed.
Thank you, Dean, for the humble introduction. I am called Nicholas Walter NZALA. The title of my research is Developing Inverse Artificial Neural Network Algorithms for the Retrieval of Meteorological Parameters. I have been supervised by Associate Professor Tadeo Senyonga, Dr. Nicholas Sevionga, and Dr. Dennis Oyinga. The order of my presentation is as indicated there, starting with the background of the subject, and to move through those stages.
Please speak from the podium, because we have members of the public online, so that they can hear you. Please don't move away from the podium.
Okay, thank you.
Make sure you can see the screen that you're pointing.
Okay, thank you. And the research is about meteorological parameters, because meteorological parameters impact our lives and life levels. Solar radiation energy is the primary natural source of energy on planet Earth. If you look at that first diagram, that sub-figure, the transportation system here in Kampala and everywhere in Uganda, involving the borders, the motorcycles, uses petrol, diesel, and all that originates from solar radiation energy. If you look at the second sub-figure here, and somebody happily harvesting food, that food is a result of a process of photosynthesis in which solar energy is converted into chemical energy through the manufacture or the construction of energy-rich organic compounds. It is when the animals and dead plants that have life sustained and grow due to the food produced due to photosynthesis, when they die and they decompose into fossil fuels, which give rise to the fuel we use in cars. The hydropower electricity here produced is a result of the hydrological cycle. And solar radiation energy is the main driver of the hydrological cycle, in which water in the seas, oceans, and on land is heated, evaporates into space, and cools, then falls back as precipitation, either as rainfall, sleet, or snow. It is the hydrological cycle, mainly driven by solar radiation energy, that enables the continuous flow of rivers, which we can tap and harvest hydroelectricity. Solar radiation, and they harvested directly here, seen by this oh my God. Yeah, use it. Manual. Okay. Okay. Here, sorry. Solar radiation energy can be harvested directly via photovoltaics and used, for example, in irrigation of agriculture, to promote agriculture. It can also be harvested directly in sub-figure 2 and used for cooking and heating of water. Solar radiation energy can also be used domestically and at industrial level as dryers for coffee dryers to dry coffee more effectively. Sunshine hours data is required for the quantification of climate change and the quantification of photovoltaic potential in particular areas. It is sunshine hours are also necessary to quantify and improve heliostats technology in which sunlight is used into large interior buildings for lighting. Relatively limited data is needed to control risks against hyperthermia. Hyperthermia are conditions where the body is not letting out heat well and consequently can lead to strokes. Relatively limited is also important because it determines the rate of growth and the quality of yield of crops. Ambient temperature affects human body comfort. But more important, the rapid change in ambient temperature can result in very serious impacts on the respiratory and cardiovascular systems of us human beings. We need to know so that we guard against such risks. Prediction of climate conditions is important in order to be able to attain the Sustainable Development Goals, the Vision 2040 and the current National Development Plan, all of which are geared towards transforming our country, Uganda, from a peasant economy to a prosperous, modern economy. Globally and nationally, data for weather prediction is not sufficient, as cited by the NZALA. Infrastructural network algorithms adds on to the efforts of acquiring large data sets. In Uganda and in many parts of the world, artificial neural networks have been largely used in forward movement to obtain solar radiation energy levels. In this research, inverse artificial neural network algorithms have been used to retrieve meteorological parameters based on solar radiation. This brings us the statement of the problem. Globally, anthropogenic activities have increased weather variability, posing significant threats to human life and livelihood. Accurate weather predictions are essential for ensuring food security, disaster preparedness, and sustainable development. However, the high cost of acquiring meteorological equipment and maintaining them has resulted in a severe lack of critical meteorological data in many developing countries, hindering effective weather forecasting. To address this challenge, this research aims to develop innovative inverse artificial neural network algorithms that can accurately derive some of essential meteorological parameters such as air temperature, relative humidity, sunshine hours, and rainfall used in weather forecasting solely from regular available solar radiation data. By leveraging solar radiation data, this research seeks to improve weather prediction capabilities in regions where some measuring equipment is lacking, ultimately enhancing the resilience and well-being of communities in the region. The general objective of this research was to develop inverse artificial neural network algorithms to predict meteorological parameters based on solar radiation data. The specific objectives were three. One, developing an inverse algorithm that predicts sunshine hours based on solar radiation, global horizontal solar radiation. The second was to develop an inverse algorithm that simultaneously predicts two parameters based on local horizontal solar radiation. And the third specific objective was to create a reverse algorithm that extracts simultaneously three meteorological parameters based on global horizontal solar radiation. The significance of this research is that large data sets of meteorological parameters required by several organizations such as the Ministry of Agriculture, Animal Industry and Fisheries, the National Planning Authority, the Civil Aviation Authority, will be obtained and used for planning and mitigation measures to execute their mandate better. The data will enhance attainment of sustainable developments 2, 11, and 13, whereby in 2, the goal talks about ending hunger in all its forms through increasing and modernizing of agriculture. Sustainable development 11 talks about making cities more available, more comfortable, and resilient for inclusive for human settlement. And settlement problem 13 is taking urgent measures to contain climate change repercussions. The new Vision 2040 objectives 4.11 and up to 4.17 are about one, promoting tourism within the country, which goes a long way to promote the economy. Two, to modernize agriculture. And the third one there is to employ ICT in a way that is developmental to the country and communities. The National Development Plan 3 picked three of the objectives, and one of them was to modernize agriculture. 8.3.1 is to promote tourism, and 9.3.1 is to take measures to combat climate change. The justification of this research is that using artificial neural network inverse algorithms, a lot of that we talk about has been properly derived for the different climatological and geographical zones of Uganda using a single measurement equipment at a locality. In literature review, it is observed that solar radiation here at the atmosphere, at the top of the atmosphere, here, this white band here, travels through four major layers: the thermosphere, the mesosphere, and the stratosphere, and troposphere, to reach the Earth. In the process, solar radiation energy is attenuated as shown in this diagram here. It is reflected by clouds, it is scattered by the atmosphere, it is absorbed, such that eventually only a fraction of the solar radiation energy incident at the top of the atmosphere reaches here as direct solar beam, while another solar fraction, and depending on the part of the day, reaches the surface of the Earth as a scattered solar beam. This research was about global horizontal solar radiation, which is the sum of the direct beam and the scattered beam. By considering a pencil of solar energy incident normally on a small area, dA, we were able to define spectral intensity, I at a specified wavelength, nu, as the ratio of the radiant energy dE that crosses unit area per wavelength change or interval at a specified wavelength per solid angle per second. Now, when solar radiation moves from the sun and travels through a vacuum, the spectral intensity remains unchanged. That is, the medium neither scatters nor emits, neither absorbs the radiation. But right from the top of the atmosphere, as the solar radiation traverses the atmosphere down the surface of the Earth, solar radiation energy undergoes absorption, emission, reflection, and scattering. The change in the solar radiation energy with length, shown in equation 2, at a specified length, is given as J nu minus alpha nu I nu. And this is referred to as the radiative transfer, the one-dimensional radiative transfer equation, where J nu is the emissivity. The emissivity of a medium is the ratio of the radiant energy that the medium emits at specified temperature to the radiant energy emitted by a black body at the same temperature. While absorption coefficient alpha nu is the ratio of the radiant energy absorbed by the medium after traversing 1 meter of the medium to the radiant energy incident on that medium. Radiative transfer equation is often expressed in terms of optical depth, which is a measure of the opacity of the medium as a whole, as given in equation 3, where the I nu, the tau nu being the optical depth, is equal to S nu minus I nu. S nu is the source function. The source function is the ratio of the emissivity, J nu, to the absorption coefficient. Current and retrieval algorithms. In this research, we employed retrieval or using inverse artificial neural networks. In the inverse retrieval, there is a change whereby the variables which are dependent become the inputs to the algorithm, while the independent variables are the outputs. So there is a change of order, because most functions work in the order of independent variables as the inputs, giving output, the dependent variables as the output. In any algorithm, and including the algorithm that we constructed, the order is reversed. Any algorithm works on the principle of optimization. Optimization is the process in which we search for the minimum or the maximum value of a process, and that is searched within a function, usually based on cost. Researchers have employed inverse artificial neural network algorithms to retrieve marine and aerosol parameters in coastal waters basing on reflectances, normally given by satellites. And this was the case with Stamnes and the case with the Senyonga et al. In this research, the inverse artificial neural network algorithms were employed to retrieve terrestrial meteorological parameters within sub-Saharan region based on ground measured solar radiation values. This now brings me to the conceptual framework. When research is done basing on variables rather than theories and principles, then the conceptual framework will be known as a model, as guided by Tabarino et al. 2009. Dear scholars present here and the scholars online, allow me today to unveil before you the NZALA Army model. It has or consists of two parts. The first part is the training of the feed-forward artificial neural network. And the second part, oh my God, involves the retrieval of the paper.
There is a button at the front of that pointer, the button at the front.
Yes.
Yeah, that's for the light. Keep your hand there.
This one?
The arrows use the front. Yeah, that one.
This one.
Use the button.
The front. So avoid the arrows. Make sure your finger doesn't touch the arrows. The arrows on the pointer.
So, in the first part, it involves selecting of a training function for an artificial neural network. And then the other is trained using a data set. It is tested and evaluated, and then it is saved. In the first part, the other parameters which we need to retrieve were the inputs to the feed-forward artificial neural networks. Solar radiation energy was the output to that feed-forward artificial neural network. After training thoroughly and being sure of this feed-forward artificial neural network, it is saved and used in the second part, which is the part of our interest. In the second part, a retrieval algorithm is employed, optimization function is employed. And in this process, now, the global horizontal radiation data, which is not part or was not part of the data used in the first part for training will be the input to the algorithm. There is a function, the optimization function, which optimizes the cost function and also makes use of the saved feed-forward artificial neural network in optimizing the cost function. In that procedure, the parameters that were initially inputs are now the one retrieved, but from different data. In the methodology, one data for the algorithms was obtained and measured at 2 locations within Makerere University. One at the Uganda National Meteorological Authority Makerere Weather Station, and the other at the Physics Department of Makerere University. There are several instruments that were used, including the pyranometer, the sunshine sensor, duration sensor, pluviometer, the thermometers. The instruments were calibrated regularly during that time. The working principles of these instruments are given in the thesis book. The other tool that was used in this research were the artificial neural networks. Now, what are artificial neural networks? These are information processing elements that are instantiated in software that run on digital computer systems. The artificial neuron mimics the functionality of the biological neuron as shown there. The biological neuron, information is received through the dendrites. It is processed by the cell body called the soma, and if the information is strong enough, it is ejected via the hilo at the bottom of the soma and travels through the axon to the other neurons as output. The final stages are bulb-like ends called the synapses, which connect the biological neuron to other neurons. There are many biological neurons, estimated to be 100 billion, and they process information in parallel. The processing element of one artificial neural network is the perceptron, shown in figure P here. In the perceptron, each input to the perceptron is multiplied through a weight and then sound. To the weight is added a bias to get the total strength of the signal. Now, that determines, the bias determines the conditional processing of the signal. If the signal is strong enough, it is processed by an activation function. If it's weak, then it's not processed. It's not relevant. It's processed by an activation function and we get an output very similar to that of the biological neuron. Now, the perceptron was found through developments to be not so efficient in processing information. And the developments came up with the multi-layer perceptron, which consists of at least 3 layers: the input layer, the hidden layer, and the output layer. And one of the kind of multi-layer perceptron was used, called the radio basis function, was used in this research. Radio basis functions, something as activation functions, are characterized by the fact that the response to an input either continuously decreases with distance from the distance of the output from the center, or continually increases. In this research, the Gaussian radio basis function, because there are many, there is the Gaussian, the multiquadrat, and the inverse multiquadrat. But the Gaussian basis function was found to be most stable, even by equation 4, was employed in this research, where X is the input, C are the centers of the clusters, followed by radio basis function, R is the radius, and H is the response. The radio basis function neural network given by the equation was the one employed in the process of training and getting the global horizontal radiation in the first part. In this one, HI represents the global horizontal solar radiation, while while RK are the inputs. N is the total number of input parameters to the network, while N, at the beginning, capital N there, represents the number of neurons in the hidden layer. The inverse artificial neural network method involved the following steps. One, training the feed forward as explained in the conceptual framework, and serving it. Then it was used by the same function to simulate solar radiation values based on the retrieval parameters. And then, starting with an initial guess, the network must be given a guess. The retrieval algorithm parameter, the same function, predicts a solar radiation. And then the optimization function, the cost function computed the difference between the values given by the self-D radio basis function neural network, and that measured by the parameter. That's called the cost. And then the F-min search, minimize the cost function using the nail-the-meat technique. Now, dear scholars, the nail-the-meat technique constitutes the center of gravity of this research. The nail-the-meat technique optimizes functional values without calculating their gradients. Take a case of a two-dimensional parameter input, if that's what we want to retrieve. This one here, sorry, this one has really not been very good at this here. I can see it now. Here can be represented in this sub-figure as a point. That's a two-dimensional data that we need to retrieve based on non-horizontal solar radiation. The first step follows adding 5% to each of the components, X1 and Y1. So here we have added 5% to Y1, keep the X1, to X1, keep the Y1, and here Y1. And then you now generate what's called a simplex. And the aim is to minimize the diameter. Yes? In the, okay. So, now it adds 5% to each of the components and then computes the function value at each of the nodes. Now, supposing the top node is the worst, performing the worst functional values, then it undertakes 4 steps, and in each step it eliminates the worst functional value and incorporates a new functional value. The steps are reflection to rule the centroid of the simplex. It is expansion. If the reflected point is not good enough, it will now do, if the reflected point is good, so that it's better than all the functional values earlier on, it will continue an expansion in these figures D, and then if the expansion does not yield good functional values, it will do a contraction. There are 2 types of contraction, the outside contraction and the inside contraction, and then it can do a shrinkage. In all these processes, it is to get a function value of the cost function which is so small. We use the very many statistical tools to evaluate the performance of these algorithms, including the correlation coefficient given by equation 6, the mean bias by equation 7, the root mean square error given by equation 8, and the mean absolute percentage error given by equation 9. In each of these equations, YIP represents the predicted value and YIM represents the measured values. YIP bar is the average of all the predicted values, while YIM bar is the average of all the measured values. Capital N in this equation represents the total number of the measured values. A large correlation coefficient whose magnitude is towards 1, like between 0.7 and 0.9 and 1, represents very good model performance. A low mean bias value, almost around 0, represents good model performance. A positive mean bias value represents underestimation by the model, while negative mean bias value represents underestimation. Root mean square error given in equation 8 and the mapping give the short-term performing characteristics of the model, while the mean bias informs us about the long-term characteristic performance of the market. This is how the conceptual framework and the other methodologies were applied to execute specific objective 1. In the first part of this specific objective execution, sunshine hours were the input and global horizontal solar radiation was the output. The data, training data set, the data was divided into 2 parts, 90% for training and 10% for retrieval in the second part, after the training. And MATLAB function, MATLAB software was used in this. In the second part, specific objective 2, monthly average values of the measurements of the meteorological parameters were calculated. And then the training was done using radio basis function as the activation function. We used the K-means clustering algorithm to determine the centers of the radio basis function equation, whereas the spread was explored as a design parameter. The statistical tools I mentioned above were used in the execution of this. In specific objective 3, it was similar to that of specific objective 2, only that here we used 3 meteorological parameters simultaneously, both in the feed-forward training and also the inverse parameter retrieval. The sim function was again used and F-min-sat function was used. This brings me to the results. Dear scholars, for specific objective 1, the RBF neural network, for the first part, with 47 neurons in the hidden layer, and a spread of 10, presented the least mean square error and was had the highest correlation coefficient. So was the one which was saved. The correlation coefficients in the feed-forward part were as indicated in those diagrams. We had correlation coefficient of 0.93, mean bias of 0.17%, and mean square error of 1.6 megajoules per meter squared. We went on further to compare the predicted values with the measured values of global horizontal solar radiation using a ratio plot. In this ratio plot, it was observed that 95% of the data points lay in the range between 0.8 and 1.2. For an ideal tool which retrieves accurately, the ratio will be 1. The fact that most of the values were within a narrow range about 1 indicated strong performance. In the inverse retrieval part, where global horizontal solar radiation was now the input from the unseen data and sunshine hours was the output, the ANI algorithm performed as indicated in the diagram with a correlation coefficient of 0.93 and mean bias of 5.6% and a mean square error of 0.97 hours. The ratio plots in a similar fashion indicated that 94% of the ratio plots were in the range between 0.5 and 1.5, again showing a strong performance of these algorithms. All that I've explained is what is on this slide. But then, just taking a bit back, we got concerned with some of the outlier points. Clearly, the one up, this one's below, were not performing well, and therefore divided the data into 4 categories to try and explore whether there was a relation in good performance to the amount of sunshine hours of that day. In the division here, we have the first category for all sunshine hours measured, and here we categorize only sunshine hours greater than 3, greater than 5, and greater than 7. It was observed, as shown in this table, table 1, that the mean bias value reduced. Remember, the smaller the mean bias value, the better the model performance. Reduced as the sunshine hour threshold increased. The percentage of data points in the range, -10 to 10%, the relative difference was also increasing, showing that more data points were closer to the ideal tool. It implied that those days with greater sunshine hours are normally or associated with clear sky days. This indicated that the algorithm performed better for clear sky days as compared to cloudy days. Cloudy days are known to attenuate solar radiation significantly and making retrieval difficult. In second objective, we formed 7 pairs of meteorological parameters and then trained them in the feed forward. The algorithms that were trained performed with correlation coefficient in the range 0.8 here to 0.96. In the feed forward, there was improvement. Even the mean bias was smaller compared to the one algorithm, as indicated here. So the performance of the algorithm, the feed forward, improved in this case. And then we used the same feed forward actual network in the inverse retrieval part. And this is what was obtained. For each pair retrieved simultaneously, we compared the values retrieved of each meteorological parameter to those measured by the instruments. For example, the best performing pair was the pair of sunshine hours and maximum temperature. Now, when they were retrieved simultaneously, the sunshine hours had a correlation coefficient of 0.84 between the tool retrieved and the sensor measured values, and the mean bias of 90%, and that's a good performance. Root mean square error of 0.81, while the maximum temperature value had a correlation coefficient of 0.87, mean bias of minus 0.12%, and the root mean square error of 0.5. The minus indicates that the model slightly underestimated maximum temperature values, but in an acceptable range. These are the details of the performance of the other pairs. The ones of relative humidity with maximum temperature, down the one of relative humidity and rainfall. The one of rainfall really did not perform well with a large correlation MAPE, which is an outlier in this research. For the determining retrieval algorithm for the 3 meteorological parameters based on solar radiation, we constituted 5 sets, each set consisting of 3 meteorological parameters. And then for each set, we trained a feed forward radio basis function, saved it, and then used it, the ANSYS data, in retrieving the meteorological parameters. The feed forward radio basis function neural network showed improved performance. The correlation coefficient went up to 0.97. In fact, the correlation coefficient of all the 5 sets was between 0.95 and 0.97, and it showed good algorithm performance. The correlation coefficient of the other parameters are shown here in the table, indicating good parameter performance. Now, this was compared by the works of earlier researchers such as Plasma, who predicted mean monthly radiation based on 5 meteorological parameters, who got coefficient of determination of 0.96. We also compared with scholars such as Mubiwandi Banda, who predicted solar radiation based on 3 meteorological and 3 geographical parameters. They obtained correlation coefficient of 0.974, implying that our performance was comparable to the performance of distinguished scholars. In the inverse retrieval part, the parameters were retrieved with correlation coefficient ranging between 0.15 to 0.93. The root mean square in that range, and the MAPE also in the ranges given there. The ANIT most accurately retrieved the set of sunshine hours, relative humidity, and average temperature, with correlation coefficient indicated in this diagram. Sunshine hours was retrieved with correlation coefficient of 0.73, whereas relative humidity had correlation coefficient of 0.57, and average temperature 0.61. The root mean square values are indicated there, 0.97, and all the others. This pair, this set, had a correlation coefficient of all the parameters above 0.5. Now, according to Azuero, the model whose correlation coefficient is above 0.5, or between 0.5 and 0.7, is said to be moderate. And therefore, a large extent, the performance of these models is acceptable. The results of the other sets are given in this table, whereby we could see particular sets performing better for particular parameters. For example, the first set with sunshine hours, relative humidity and maximum temperature performed best with sunshine hours, in which free sunshine hours, the evaluation coefficient of 0.93, mean bias of 0.05, and root mean square error of 0.59. In the conclusions, dear scholars, here, one, the objectives of this research were met in that inverse artificial neural network algorithms that can retrieve sunshine hours, that can retrieve ambient temperature, that can retrieve rainfall, and relative humidity were constructed. In particular, the early algorithm for the retrieval of one parameter retrieved the sunshine hours very impressively with a correlation coefficient of 0.93, with a mean bias of 5.6%, and with the root mean square error of 0.97 hours. While the one for the simultaneous retrieval of two meteorological parameters performed the best for the pair of sunshine hours and maximum temperatures, which were retrieved with correlation coefficients 0.84 and 0.87 respectively. The other parameters, values, mean bias are given. I found them. And then the inverse retrieval for three parameters retrieved most accurately the set with sunshine hours, relative humidity, and average temperature. The correlation coefficients of 0.73, 0.57, and 0.61. The algorithms for the simultaneous retrieval of two parameters can be used for the retrieval of maximum temperature only, or for the retrieval of relative humidity only. The early algorithms can be used to get values of meteorological parameters where the other equipment are lacking, but we have solar radiation values or solar measurement values. We recommended in this research that early algorithm for the simultaneous retrieval of two parameters, 4, 5, 6, be constructed. We also think it's good to construct inverse artificial network algorithms that can retrieve our measured parameters, because this is important for our casting. And the retrieval algorithm for the measured parameters for global days be constructed. These are some of the references used, and then two publications recently are also given. I want to thank you for listening to my presentation.
Thank you very much, Mr. NZALA, for that insightful presentation, very informative. Let's now move on to the next part of this process, which is engagement with discussant. I'm going to press sit over here, he's going to sit here. Please come and sit here, make sure you're comfortable. And have your, I don't know, you can pull your computer next to you. Yeah, so that you have your computer, have your dissertations, have pen and paper, so that we can then get this discussion properly done. take this opportunity to once again welcome Dr. James Ngiro. Thank you very much, sir, for taking time yet again engage with our students and improve with the work that we have undertaken. We very much appreciate your time. And we briefly introduce the discussant today, Dr. James Ngiro. He has a BSc, Bachelor of Science from Makerere University, obtained in 1996, majoring in mathematics, psychology, and physics. Then he went on to obtain a Master of Science from Makerere University in physics, where he obtained in October 2000, had a dissertation titled Study of Diffuse and Beam Solar Radiation on the Horizontal Surface. And then he got a PhD of Makerere University in physics, obtained in September 2007, where he wrote a thesis titled Development of an Appropriate Solar Radiation Map for Uganda. His experience includes his taught several undergraduate courses in solid state physics, material science, solar energy, wave optics, and so on. He has also taught graduate courses to include research methods and classical electrodynamics. He has been involved in research studies in the area of measurement and modeling of solar radiation, and in the process of supervision of several MSc students. He has been an external examiner for several universities, including Makerere University, Mbarara University of Science and Technology, International School of Business and Technology, among others. He has also participated in the review of several journal articles of several reputed journals, including Solar Energy Elsevier, Applied Energy Elsevier, Chemical Product and Processing Modeling Vacuum Electronics Press, Journal of Biotechnology, Journal of Agricultural Science and Technology, Journal of Bureau Computing and Applications, Measurement Journal, Sustainable Energy Technologies and Assessment, Journal of Atmospheric and Solar Terrestrial Physics, and Institute of Electrical and Electronics Engineers Systems Journal. He has also reviewed a chapter titled Recent Advances of Modeling Solar Radiation on Earth's Surface by Springer Publishing House. He's affiliated several organizations, including the National Solar Energy Society, ISES, since 1999, Project Management Institute, PMI, since 2013, Information Systems Audit and Control Association, ISACA, since 2018, and the Chartered Management Institute of the UK. Dr. Ngiro has written several scientific articles, 16 refereed, proceedings, and book articles. He has also authored 2 books in the field of information technology. Thank you very much, Dr. Ngiro. Once again, we want to welcome you to this stage of this process, and we're going to have up to 45 minutes to engage the candidate. Welcome.
Thank you. Thank you, Dr. Hall. And it's my pleasure to engage Mr. Wonder. I've listened to your presentation, I've read your thesis, and I just want to welcome you as part of the process, welcome you that area where you have contributed knowledge. You need to contribute knowledge, and the level where you are presenting the work is where we are looking at originality. Because at the end of the day, we want to appreciate you as you contribute to the world of knowledge. Now, this research area is rather interesting. I'll point out some key statements in your problem statement. Is where we have a statement that accurate weather predictions are essential for ensuring food security, disaster preparedness, and sustainable development. And then the report further, the thesis further says, within the same paragraph, that by leveraging soil radiation data, this research seeks to improve weather prediction capabilities in regions where some measuring equipment is lacking, ultimately enhancing the resilience and well-being of communities in the region. Now, this is a very strong statement. Very strong statement in the sense that you're connecting what you're doing to what is required out there. So I'd like to commend you for that. So as presented by the author in his presentation, that's Walter, as well as cited in the thesis, the study seeks to develop inverse artificial neural network that predicts meteorological parameters based on soil radiation. While many studies nationally within the region and international focused on feed forward, for you to say to reverse the whole thing and do what others haven't done for this particular area, it's synonymous to sleeping in a bed, to make the bed sheets and the blanket one face up for so many years, then all of a sudden you say to be the other way around. So that's the originality we're looking out for. So the attempts, that's Walter, he has attempted to identify inverse algorithms which can be used to predict, I'm using your own words in the specific objectives, which later I will ask you to clarify. You identify inverse algorithms which can be used to predict, retrieve, extract meteorological parameters from the available solar radiation data. So, what inspired you to take on that approach of using the artificial neural network? Inverse.
Thank you. Yes, realizing from the literature that for the actual performance of feed-forward artificial neural networks, it is need to have many inputs. In fact, the two inputs, the three inputs, which have been compared by researchers, find that the one of more input parameters performs better. When we use more input parameters, it means we require more measurements at the locality. And the key area here, the problem we are trying to address is cost of the equipment. In instance, artificial neural network algorithms here, we see a possibility of reducing the use of parameters. Like we can see that solar radiation energy is dependent on several parameters. The amount that we receive, no horizontal, on the surface of Earth. And therefore, we sought to use a small number, as small as one parameter, input parameter, to be able to get memory. And by so doing, to really minimize on the cost, the number of equipment that we may require in order to get meteor parameter data.
Now you talk of the equipment being expensive and also the maintenance being costly. But we've been doing this research for over 10 years in the region, and we keep on fronting this as the issue. Expensive. Could it be that the other factors that impede availability of data rather than costly equipment? What's your take on that?
Well, when something is seen to be costly, then it reverberates into two other aspects. One, the performance of the economy of the government. Because most of these other stations and which are put up on government funding. And two, on the prioritizing that the government has in that area. And when we look at these two areas, I see that for the last 10, 20 years, and especially comparison to other nations, we have not changed very much economically compared to nations of the developed countries. And therefore, the problem remains. The problem, of course, remains. We have so many priorities as a nation, and we are noticing in the course of this research where there is a shift in making weather prediction like one of the priorities.
one, this is first paragraph of background study. This is a very strong statement there. The applications, the last statement in the first paragraph.
Yes.
The applications of soil irrigation can be categorized in 4 areas, and you go ahead and state the 4 areas. And my question is this your assertion? Is this your statement, or you pick it from somewhere?
I picked it from
Because if you pick it from somewhere, then you make the reference. Otherwise, I was going to congratulate you for making very strong statement. Now, the same page we have, because now, at the end of the day, we want to have a very quality document, given to the level of PhD. Even the tiniest errors or misspellings matter. Now, we have that reference, JAGA 2016, the second paragraph.
Yes.
It appears twice. JAGA will be on the A, there's those 2 dots on the first one. And then on the other one, there's nothing there. And the other one states the ETAL, meaning the other letters. The other one doesn't state that. So you need to have a consistency in that regard. So what I'll be doing is at some point in time, I will make requirements. At that time, I will make comments. So if you feel that it's something that you cannot respond there and then, just take note of that.
Yes, I'm not at this
Because we need to focus on improving matters, it's an explanation, but also need to focus on improving. Now, on the next page where we have after temperature rise occasions. Yes, but I'm particularly looking at the statement that starts with researchers. Researchers are apparently giving more attention to climate change effects in developing countries compared to the least developed countries. You stop there and then you go to something else. I feel like you need to qualify that statement. So yes, if researchers are apparently giving more attention to climate change effects in developed countries compared to the others, then what? It would be nice if you had a statement for you. Yes, suppose this one you take it from what we had reference, but now you need also at this level of presentation, you need to be able to add the word to that statement. But then there is my page 5 here, but there is a statement that makes reference to the cost of buying and installing, maintaining. I think I've already engaged on that issue of cost of equipment, so we can skip that. Now, when you go to the section of objectives, specification, and significance, now let's look at because you have a main objective, I think, yeah, main objective, and then you have the 3 specific objectives. And ideally, the specific objectives support the main. I want you in maybe a few statements, take us through that journey. How the specific objectives connect the main.
Thank you.
You don't have to do this way. Yes. I want to see the connection. Because now the main objective is supposed to be answered by the 3 that are stated in the cases.
Thank you, Doctor. Yeah, the main objective is to develop inverse artificial neural network algorithms for the retrieval of parameters. But the meteorological parameters are many, and we can retrieve them in different ways. We can retrieve them individually, but also it's possible to retrieve or get these values when the parameters are considered together as one set. So the specific objectives were focusing on how the retrievals are going to be done. Yes.
Okay, now, you remember when I was doing my introduction, that's pretty what I stated. The extract and retrieve, take them from the three specific objectives. And I'm just wondering out loud, would they be defined the same? Because the first specific objective, we talk about the global universe algorithm that predicts. The next one, the global universe algorithm that simultaneously retrieves. And then the other one, react reverse algorithm that extracts. Is that the same or?
Yes, they are referring to the same process.
Okay, just wanted to give it, to remove the numerator, if I may put it like that.
Yes, but I also found in the literature that researchers in these areas have enjoyed using the different terms and ocean fluid.
Okay, so
But basically, as they feed into the memory, they are all referring to the process of getting unknown data using known data of storage.
so it means also when you look at specific objective 3, create, that is in essence the same as before, right?
Yes.
Okay, so we still under that, page 29, I think it was where you have women, the women,
Yes.
and then there is electricity distribution company. Because you do say that electricity regulatory authority, that is ERA, and the electricity distribution company, that is women. My question is that the same? Maybe it's the same as the distribution company?
No, not really.
Okay. What else?
About the
electricity
electricity distribution company.
distribution company, and then in brackets, maybe even make which I think probably is the same, meaning that maybe is that company. And my question is that true?
I was here, Doctor, I was showing that the company for the distribution of electricity here is women currently.
Okay. Okay, the thing is that women is private operator, and they were given concession to distribute by that company. Now that company is a government entity. So the government entity, the electricity distribution company, more or less leased to women, but the two are still differentiated. Yes, in fact, if you've been keen, let's talk about women's contract not being renewed. They want now to take back the functions, back the company, and then it goes up. So such seems to be small things, but when you put them in a report like this, where people are informed, it affects the credibility of the report. So probably we make that correction. When you go to literature review, in mind is 2015, where we have figure 2.3. The figure 2.3.
Yes.
You have it in the slides. I know this is effective from the references extended. I think you're in position to flow more light, because we need to understand how it connects to the research that you're involved in. Just elaborate. What's it all about?
Yes.
Including the interpretation of the peak. Because it has a peak.
Yes. This figure 2.3 shows the attenuation of solar radiation as it moves from the surface of the sun to the surface of the earth. It also gives more clarity about the intensities within the solar radiation. The intensity is not flat. In this figure, we are also able to appreciate and look for the reason why what we have as the ideal curve, the red one, is different from that in blue and the one in black. That even within the atmosphere of the sun, some absorption takes place, and discuss some of the
radiation that comes. But better still, when we look at this, the black curve compared to the blue curve, because the black curve shows the intensities of the solar radiation after traversing. Moreover, that one is at air mass 1.5, meaning covering a greater length within the atmosphere as compared to solar radiation at the zenith. And it shows clear that the more it passes through the atmosphere, the longer that the more it suffers attenuation. Eventually, this curve helps to explain that solar radiation energy is not easily deterministic, that we cannot easily get a relation with it because it has many factors and fluctuations, and also gives credibility to artificial neural networks, because they are being created with working about complex functions. They can trace out all these ones and still map out some connection and help us in the retrieval process.
Okay. Now we go to the next page, section 2.3.2. We seem to be missing some content there, or maybe it is because now, even when you look at the table of contents, when you look at the table of contents, chapter 2, section 2.3, radiation of the Earth's surface, and then you have 1, 2, 3, 4, 5, 6 sections. Now the first section is okay, then it comes to section 2.3.2. We don't have anything in there, and immediately we go to section 2.3.2. You have an idea of is it that content is missing, or that there is a mismatch in the way we go to things? So, yeah.
Yes. Yes, I realized that subsection is
At first I thought it was, the effect of scattering was a sub of that one, but then I realized that they are the same level, 2.3.2 then 2.3.3. So which means it's on this point. There has to be some content in there. You look at it.
I removed it as a subsection heading, but the content was put in one of these sections.
Now, in the next pages, 16, 17, 18, I make up for those. I think I'll point out specific areas. Under the effect of scattering is where we mentioned that in the wave theory, in the wave theory, the different forms of scattering, not the word forms of scattering. Then, when you go to the next page, there are 3 types of scattering. Not the word type. The other is forms of scattering. These are types of scattering. And then the third, we go to the next page, we have the 2 dominant scattering regimes. So we have forms of scattering, we have types of scattering, and then we have the regimes for scattering. Are you able to differentiate between the 3? Because each of them points to something different. How can you elaborate?
Yeah. When we talk about the dominant scattering regimes, it was mostly the regular scattering and the new scattering. When I look at the different forms of scattering, I was looking at the whole wide spectrum of scattering, which included that one, the scattering, the passive scattering, whereby the inelastic scattering, where there is change.
Now, you free to look at the report because the different forms of scattering you stated are reflection, refraction, and diffraction. Those are the forms under the effects of scattering. forms are reflection, refraction, and diffraction. And then the types of scattering will be stated elastic, inelastic, and quasi-elastic. I just wanted to be able to appreciate what you're trying to put forward in terms of forms, types, and then the regimes.
In terms of types, I was looking at the change in the wavelength or the frequency of the radiation as opposed to the pattern. While when here we look at the forms, the reflection and the light, we look at the paths that are taken after the scattering.
Okay, now on that page under the effect of scattering, just want to provide it. We have where the matter is composed of atoms that consist of discrete electric charges, the positively charged protons in the nucleus, and the negatively charged electrons. Is that okay? What are protons? Protons are already positive, right? Do we need to say positively charged protons? I need to get it. Then you have negatively charged electrons. Electrons are already negative. We need to state that negative charged electrons because we don't have positive charged electrons. But I needed to be guided on that. Maybe I have to know.
Doctor, I was just trying to emphasize the point of the difference in the charges.
Yes.
But I appreciate the guidance.
Then, page 21 is under solar radiation modeling tools, section 2.4. 2.4. In the first paragraph, there is a statement there: artificial intelligence methods. The last statement, first paragraph.
Yes.
Artificial intelligence methods are broadly divided into two types: feed-forward and reverse retrieval algorithms. Now, in this room, I can guarantee you there will be some people who ask against this. Because what is artificial intelligence? Because when you talk about artificial intelligence types, what comes to mind is machine learning, there's natural language programming, there is computer vision. Those are my understanding, the types of artificial intelligence. Perhaps you meant artificial intelligence.
Yes, indeed. I was referring to artificial network, but also looking at because when I use the word, I look at major divisions. But within the major divisions, indeed, it is true there are no other.
Because now when you look at those major divisions, then this is not right. Because when even a person who's not a physicist speaks, it could be a computer science, he will argue that artificial intelligence is not made up of discrete types. So these are focused, I think, on neural networks, but artificial intelligence, computer vision and all that,
Yes.
machine learning, deep something. So you need to look into that and confirm that you need to adjust, then I will rectify that we adjust that. Now, page 22, this is still under the same section. Still under the same section. It's a statement, the model had the mean relative percentage error of 2.12%. Now, my concern here is what is MPE for? It's mean percentage error, right? MPE.
Yes.
But we have that one here.
Yes.
Is that in order to fit it in there?
No, Doctor, this was an oversight of correctly isolated. Yes.
Then the next page, where we have a reference by who, H-O-U, I don't know how you can pronounce that. Who, and others, 2022. Yes. Developed an hybrid model that combined the persistence symbol, the Markov chain model, and the neighbor inference through cloud moving and so on. My question here is, can you throw more light on the persistence symbol, if at all you can? Because later on, you go ahead and even say that they realize a reduction of that percentage in the mid-monthly error compared to the model that uses the traditional persistence method. I'm wondering what method this one is.
I've not read much on the persistence models, but here I was highlighting other models that use stochastic approaches to model the solar application.
Then in the same page is that other reference for Boyard, and others 2014. This again is about being mindful of detail. When you read that gentleman or lady, I don't know, propose the hybrid models of prediction of soil relation relevant to the EVs, then it goes ahead to go ahead to say the model produced a normalized root mean square error. In brackets you have RR MSE. That is relative root mean square error. But then the statement makes normalized root mean square error. That's again to do with the small things that mean a lot of something, especially when it comes to issues of error. In physics, you know, it's a big deal. Then the next page is where we have reference to regression coefficient. Log scale and regression coefficient value of 0.99. Are you able to see that?
Yes.
Is that okay? Can we have some light, please? Some light. So we have, are you there? Is where we have the neatest values predicted by the model match the standard data sets with an average percentage of that of 6 in the log scale. Have you seen that statement? The paragraph starts with numerical models. So when you move in there, it's probably towards the bottom of that paragraph. Is where we have log scale,
Yes.
regression coefficient. Is that right? That R square. Is that a regression coefficient? So again, that's the detail. You need to be mindful of that. Then we have the next page, and section 2.5 models used to predict numerical parameters. And you made reference to an article that was written by Mobiru in 2011, and you stated equations 2.17 and 2.18. Are you there?
Yes.
Now, when you look at that particular article, what you're stating as the H bar D is actually stated as H bar B. B for beam. B, if you look at the reading article,
Not
B for beam. Beam being the direct.
yeah.
Because the good thing here is you went ahead to redefine. You did the HD, you adjusted someone's equation, and then you went ahead and defined it rightly. But I think when you're making reference to those articles, Yano articles, you need to take the model as is. So that is something. And therefore, you're most likely going to also make some adjustments in the nomenclature. Because the nomenclature, you have some definition there.
It is not.
So take note of that. Now, when I was looking at the introduction, I was really looking forward to the conception framework. And when I was done with the introduction, I was like, okay, I think he missed it out. Maybe it's not as I do the literature review, I see it at the end of literature review. Probably it's the right position, but I don't know what the university format is, because I'm not having it as part of the introduction. Because now the author, the reader, whoever is looking at the work, wants to have that big idea before they dive into the text. So it's better to have it somewhere in between there, maybe before the end of the introduction. But this is something we can discuss with the scholars. Because also you need to align the presentation of the universities. Yes. But I give you credit for elaborating it because you explained it very well when you read the presentation. So commend you for that. So generally, under the section on literature review, I have a closing statement there that I felt like, yes, you've stated all this work that has been done. I felt that you didn't ably get the gaps. Yes, people have done this, have done this, which probably you're building a case to support, justify what you need to do. But when you're reviewing literature or works that have been done, I think it's also important to identify these gaps. Because at the end of it, we want to see whether your work has helped in closing those gaps. Because the reason why you're doing literature is to be able to identify those gaps and see where your study fits in, where you can come in to help. So I feel you need to look out for those gaps and maybe put one of those settings in that regard. But probably for which. What others do is if they review literature, they even put it in a table and say this reference, this is what the description of what they did, this is what they fell short, or this is what they recommend for further studies. So they have some kind of table and they're able to use that as justification for the work. But that's a general statement. But also, I felt like there's quite a bit of work that has been done in the region, which have not been cited. So that is probably teacher work. You need to read the resources, especially at this level of philosophy. They want evidence. They want to see that you're exhausted. And your work, that the work you're presenting has been able to justify. And one of the ways to do that is really to be easy for us literary review. So I felt that it had been more work that should have been different, but I think that is for the future. Now when we go to materials and methods, you have that beautiful figure 3.1, which looks like it should be in the museum. But my comment there is, do you have any comment on this calibration status? I know the data set used runs from 2011 to 2016. Did you get assurance that during that time the sensors were well calibrated and all that? What's the assurance? What assurance do you have when it comes to calibration? I know there is a section where you talked about it, but I want to hear it from you.
Who was in charge of the latest calibration was 2013 for those instruments.
I recommend if you have the finances once a year or every 2 years. But you know, when you present, when the work revolves around data, some people are very specific on the quality of data. Otherwise, they will discredit whatever comes in. So that's why it's important that you have that assurance that the sensors or equipment using our standard. And also, when it comes to presenting the results, especially in the physics world, we mind so much about the errors, treatment of error. And so, we shall talk about that in the class section. So passionate about that. Now, the section 37, just look out for a statement that has humidity, relative humidity at 9 hours and 15 hours.
under psychometry.
And below figure 3.3,
Yes.
but below equation 3.5 is a statement. A psychometric slide ruler constructed from psychometric tables was used to determine the relative humidity at 9 hours and 10 hours of time, and then you take an average, and then you take that as the daily value, right?
Yes.
So what's your comment on the reliability of such a figure? Because you take it twice a day.
Yes.
I know problem. Now, what's the reliability? What assurance did they give?
Yes, there are challenges indeed, because these meteorological parameters, especially in the troposphere, they really can change up. But when we are taking at 9 hours, that is like mid-morning, and at 15 hours, that's like mid of the afternoon, I think it gives a better, the average of that gives a better picture. But we should also have in mind that a rough picture, because the rough limited value and tropospheric parameters can change. But they can idea this.
Okay, now if you dive into the method, I think that is page 45 here, but I will point you to section 3.4.5 artificial neural network. I think this is your set of process. We will go to now the definition of sigmoid function. Sigmoid function. That is where we have 1, 2, 3, 4, 5, 6, 8, 6 further. Since in visualization prediction models, that's part of
Yes.
yeah, since in the solar radiation prediction models, the output is positive, is a positive number, the sigmoid function given by equation 3.13. I'm aware there are two types of sigmoid models. I don't know if I'm using this. First of all, we agree that sigmoid alone has categories.
Yes.
Okay.
Tan sigmoid and they are also.
So what I'm using?
This was tan sigmoid.
Because we just take it. And is that what was used in the training when the previous
Yes, but that is only for that, but not in the radio dysfunctions, because there is a small cut at the end when we are trying to employ 11 mark rate algorithm in some kind of application of this data that we retrieve. That's when this comes in. But the bulk of this work did not use this. It was used the radio basis function.
but you used it at some point in time?
Yes.
And you say the focus was on target?
Yes.
Not long. Then it's where we have this statement that there are more than 12 algorithms. It's the same.
Yes.
There are more than 12 algorithms that can be used to adjust the weights of artificial neural network to get the desired outputs. This includes stated 8.
Yes.
But you're saying that there are 12 algorithms. There are more than
12.
And then you state 8.
Some.
No, my problem is that that what this includes. I think probably what you've done, you don't have to say all of them. You probably just say that there are more than 12 algorithms, blah, 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 and include some of, then you give this an example so that you don't tie yourself to stating everything because you mentioned it. So my problem is that when you say you include, it ties you down to doing what you said up there. So that is that's what I think of organisms. And this is where you mentioned the software used. This is where you mentioned the software used in training. And go back there under section 3.6.
F means such function, which is software installed in MATLAB, and which also implements the new mechanism.
So it's like a module within MATLAB?
Yes.
Now, when you go to now, this is my favorite section, performance analysis. Page 51, 52, 53. Because it's a very important part in the job study. But my problem is that it wasn't very aligned. So, and then I'll give this. I have just 3 comments on the section. One is that reorganize the section with each performance element explicitly. What do I mean? When you look at the section performance analysis, you have the first paragraph, the mean bias, mean square error. You make a very good paragraph there. Go to second paragraph, talk about the mean square error, then you map in the same paragraph, and then you go on, and then later on you have this, towards the bottom, you now write the equations for the various performance parameters. I feel like you need to reorganize in such a way that, for instance, the mean bias error, give a brief, this equation, done. Root mean square error, give a brief, this equation, done. So that when someone is looking at that section, is able to see the flow and appreciate. But having said that, in the results, in your work, you disorganized. Line of thought.
How do you class?
Yes. So now, when you look at the work you did, studies, the results, and discussion written out shortly, you'll be focused. Performance. When you look at the performance, you focus on about 4 performance parameters. But then in this section that I'm talking about, I think you have about 9 of them. You know, there's a temptation when you're writing. You have so much information and you feel like it all has to be in the report. But for this kind of presentation, so it's good to focus, keep it focused, don't mistake what you're going to use. So my judges will appreciate those other parameters that all the 9 parameters being talked about. But I think, in my opinion, focus on the ones that you use to specify in the work. And they're about 4. I see something like equation coefficient, if you mean square error is there, unifies error. So just that is just right. And that just, yes, I think I'll just talk about that. Including the section where those elements that have been used in the present slide. Then further, they ensure consistency in their use while tackling the 3 specific objectives as we shall see. Because now, when you go to, for instance, the first of the specific objective, one for sunshine, I think you have some performance parameters stated there. When you go to the next one for specific objective number 2, there's a way, there's another format. And I think that's why one of the 3 has something different from the other. I think we need to have that consistency so that there is an appreciation of the results for a person who's looking at the 3 at a go. And one way is to have that consistency in the area. Then we have, this is just, I just want to, because you're the expert now in this, I know that we are experts, and we talked about it, the data set. We talked about training, but I needed to hear from you to comment on the nature of data set, having in mind that you need to have data that you use for training, you need to have data that can be used for testing, and data for validating. Oftentimes, testing and validating are locked up, but in my opinion, there has to be a distinction.
among them thinkers who assess that the training data set should be about 10 times the testing data set. So algorithm now makes so many efforts in the process of training. It really is to run those many cycles. And yes, so it really is. That was the rationale of developing the data set as such.
How does the radio basis work in this respect for feed-forward? Just take me in one route from when you feed in the input to the output.
The radio basis function will make some kind of local processing within the neurons. They do not run the full propagation. When the data is entered through the input layer, very little processing, almost no processing, it's just automatic. But in the hidden layer, where there are radio basis function neurons, first of all, that data is changed into higher dimensional space to make it linearly separate. And two, then that data is divided into clusters. And that's why we talk about cluster center and radio basis. Radio basis function finds it easier for process data which is divided into clusters. And then the neuron will process those clusters.
Is it a one-way movement or it has some interrelation kind of process? Or is it just one way?
It is one way, but when it reaches the radio basis function, there is a cycle within there. It's like a rotating within there to map out something before proceeding. But not the whole, like the not layer, particle where it goes all the way to the output, and then the data, the information is sent back all up to the input chain.
So yeah, because why I'm spending some bit of time here is that feed-forward, you have training. I'm now referring to feed-forward. You have training, and then hidden layer, there's neurons there. Transfer function will bring us determines that algorithm you use, and then we have that output, and then the output is compared to the target. Now, if the data is big, the data will not go back. There will be a recalculation in there, and then goes back to the output, makes that comparison. Now, the data set that is used for the training is different from data that is used in this comparison. It's different from the data. Once you've got what you want, you now compare out of that environment, and that's where validation comes in. Because I wanted to see how that relates to the basis. But you seem to be telling me that there's a lot that goes in there, and it's all less like one way.
Yes.
If I got you well.
And that's what makes them faster in that process, because of that local processing.
Now, there is still on that. Section. Section 3.8.3. No, just that. There is section 3.8.2. Training and testing of the radio basis function. Now, when you go down, even past the theta 3.7, you have those 3 points. You have, I think we need to look at the dynamic numbering. It starts from 2. Is Roman 1? Okay, I've seen it. Okay. Roman 1, Roman 2, Roman 3. Now, when you look at Roman 3, it makes reference to steps 4 and 5. Which steps are these?
Yeah, so correct. This actually is steps 2.
We make 1 and 2. Okay.
Because I looked at that, combined this one through from 3.8 to 1, and sure was recognized that the later on I organized.
Now, so what for also makes it procedures 1 and 2. That's okay?
Yes.
Now, under section 3.9, because there should always be justification to the steps we take in some of this work. I'm just curious, when you look at the pair in this section 3.9.1, just curious, you have meteorological parameters grouped into 7 pairs, and just want to know what is wrong with the pair. By that I mean, why relative cumulative maximum temperature, and then why SA to RH and so on? What informed the pairing that you have there?
Dear Doctor, I do not follow any such criteria because actually we keep more pairs than what is reported here. As many pairs as possible, there were very many, and then selected the pairs that seemed to respond well, and this kind of other poor performing results. So these ones selected were the ones to which performance.
That's a very good statement, but it's not in the report. That just fits on there. Because it was stated and said the parameters were grouped into the but here I tell you that you are quite a number. And the fact that you have to start somewhere, you zero down to this level. And you also get to work on those ones. So there has to be that kind of write-up within the support the solution. The section 3.10.2. Point 4. Yeah, section 3.10.2. We are still under materials and because there also had an issue in the next section was as a discussion. This the section that you seem to have added some work that doesn't stand out in its objectives. And I think section 3.10 will be one of them, working a bit for weather forecasting. And just wanted to know what's this based on one of the objectives, or what's this? And I think even under results, there's also a section 12A that seems to contact.
Yes. So this is not explicit stated among the objectives. But I remember at my defense of the proposal, I was challenged to show at least some way of the application, give a glimpse of how the data could be used. So I brought in this to show that really this is one of the ways that data generated using this research can be useful in predicting the next day for weather.
It's possible to, I think you need to, when you do a revision, just bring out what you just said. That this is geared towards applying what's being proposed. Because in the basis doesn't come out here. In fact, you say the third and last segment is part of the study, or dropping that only that you say, so you need to bring out that out for you to emphasize. And I think when I had a quick glimpse of the comments from the examiner, one of the examiners that there seemed to be some work that was done that is not tied to any business problems. So I also observed that. So just if it's an application, try to align so that it fits in there. Now, as I end the section, the chapter on materials and methods, check again, I feel it's all over the place. And you can put information which I feel should find its way in literature or even in part of introduction. And so we need to refocus it. We need to refocus that section. When I hear of materials and methods, one, I need to know which data you're using, for which period, what's the quality, under the quality assurance. Within the same chapter, I want to see something on error analysis. I want to see the procedures that you execute for each specific objectives, where I the objective number one, this is the procedure, explain the procedure. Two, like that. So you need to streamline so that it's very focused and readable, ideal for the person who feel that they're not spending, they're not wasting their time. So you need to focus it, but then the candidate should bring out here the methods used in study, the corresponding data is not combined, and some of the content better placed under tutorial or introduction, depending on how we see it. I think we probably have a few more minutes to go, but I'll quickly go through the results and discussion. We look at page 64. I think in there, let's say, there's the last paragraph below figure 4.2, under section 4.2. The last paragraph there, because it makes reference to, this is your comment on the preliminary data analysis, and when I read it, I must admit I was fascinated, because you mentioned the peaks of the sterilization measurements appear to coincide with the peaks of suction hours and multiplication of values. And this indicates the possibility of direct relation between the parameters. On the contrary, the peaks of sterilization appear to coincide with the drops of relative humidity values, which indicate the likelihood of an inverse relation between the parameters. Minimum temperature and rainfall do not appear to show. It's a well-written paragraph, that's what I'm going to say. Yeah, so, yes. Now, when you go to page 6, step 8, I think to be specific, it's, let's look at table 4.1. But before I do my comments, what kind of data is solar radiation and sunshine? Is it measured? Is it predicted? Both the solar radiation and the sunshine hours and the values in table 4.1. And your assertion is that you feel that with the high deviations, the deviations that you realize are attributable to the overestimation and underestimations are attributable to the cloudy day. Because that's what the statement. And these are figures, data that you take from bigger data sets. And these are daily values. One is in your statement, you say you have that the value of 0.167 hours is the lowest. But when you look at the table, I'm seeing another figure that is the lowest. For such an hours. The other figure more than 0.167.
Yeah,
Zero 0.167, you're saying it's the lowest, but I think there has to be one that lower than this. If you look at the data set of sunshine,
yes, I'm saying
which one?
0.06.
Yes, I mean the lowest. I argue that this is not the lowest. I argue either approve or disapprove.
It is not the lowest.
So which is the lowest?
I'm saying 0.067.
0.067.
67. I'm 30 to do that.
Exactly. But also I'm saying 0.150, which is what's wrong. So we being at NZALA level, we are so keen. So this is something that someone has to use. But now the problem is that when someone sees this, it affects the credibility, as small as it is. But that's not the main thing that I want to point out. You're giving the reason for the overestimation and estimation really clouded there. But when I look at these figures, could it be that probably these figures are errors, erroneous? Probably, data set may not be accurate. So we may have those, is what the statement used out there, something like that. There are those figures that seem to be out of the place. Rather than justifying that they could be attributable to clouding. Could it be that there could be errors?
Yes, Doctor, this is possible also to be errors. But here, when I compare to the larger data set, when I put that data set and arrange it in increasing order, and I saw that the sunshine hours here were mostly in that category. So, whereas I accept that instruments and even recording can have errors, but when there is something consistent for a number and it is not one, we are over 10, I think that's why I got the confidence to conclude that there will be a trend, that will be a relation.
The reason why I'm saying that is that from experience, for instance, the relation of 12.61 that last figure, 12.61 for the rest of negatives per square meter. That one, okay, in line with around 3 hours. I expect about 3 hours of sunshine, but it's showing one. When you look at the second one, 3rd of May 2011, 10.96 megajoules per square meter, I would expect that to be such an hour to be around 2 hours for that particular celebration. And then when you look at where we have the highest figure of hours for this data set, 3.31 on the 3rd of March 2016. 3 hours, normally you have celebration of about 12 megajoules per square meter, but it's almost half of that. So that seems to be confusing me, but I'll throw it back to you to take it out, that this could actually be figures that have this. But that is something that you can go back and check so that you present it appropriately within the text. Then page 69. Section 4.3.3. Yes, when you look at the heading itself, the AAI performance for 4 categories of sunshine hours. I know you took some time to explain this, but I also need to hear it again. What is the purpose of this breakdown? Because you have it in the table, you also definitely thought about it. What informed that breakdown? Why should we appreciate that?
We were trying to investigate is there a relationship between the performance of this scanning algorithm to the clearness of the sky. And in this categorization, the assumption was that a clear sky day will have more sunshine hours. And so that's why with the sunshine hour, the measured sunshine hour values to categorize this, whereby the measured values with sunshine hours greater than 7 imply that those had less cloud disturbances or there were more clear sky days compared to the ones with sunshine hours just greater than 3. The ones with sunshine hours greater than 3 had a mix of the clear sky days and the cloudy days. Whereas these ones, there is more cutting off of those cloudy days to remain with mass clear sky days.
So that the performance is better when the performance
more clear sky days.
When the station hours are
high.
when the durations.
Yes.
But you also need to carefully use that wording, sky clearness, because some anonymous other circles take that as having no cloud at all, clear, happy, different clearness. So you need to process works.
Yes.
And I need to pick it up again. But this time, I need to understand how you actually comment on the influence of the number of neurons and the spread for this kind of model. In the table here, we have 1, 2, 3, 4, 5, 6, 7 columns. The first one is setting parameters, paired parameters. Then it goes on to give the performance parameters. The second, the third, the fourth, the fifth, and then the last two have the number of neurons and hidden and also the state. So, what's your comment on the influence of the number of neurons and the state to what is trying to do?
We found no direct relation between the number of neurons in the female and the state, because there are cases where we have large number of neurons with a small spread, and also we have a large number of neurons compared to the large number compared to the large spread. So in this research, really we did find a clear relation between.
Because you need to discuss this very carefully, because now you have these paired parameters. The first one relatively to the maximum temperature, the next one is sunshine hours, the maximum temperature. And whatever results you get, you may justify giving the reason that, for instance, maximum temperature has a direct relationship with the radiation, same as applies to sunshine hours and light relativity. But it could also be possible that perhaps the number of neurons you produced affected the outcome, or even the spread.
Yes,
So
the number of neurons affects the spread and affects the performance of the model. And indeed, it is one of the areas of the investigation in this research, because the number of neurons in the area were varied. We could fix the spread via the number of neurons as much as possible, and then pick number of neurons for which there is good performance. Again, vary the spread in order to get an architecture that will produce what we call the optimum performing architecture. So in that respect, try to make as much variation between different combinations of neural number and spread.
now, if you can have a paragraph of what you just said and put it in the materials and methods section, it will make a lot of sense. What I just said, if you see it for that. Now, we take one, we are almost there, one, section 4.5. Statistical technique number 3. I was looking forward to dive into the results for that objective. Order to be first with some material there. I think you are itching to have it in there, in a section. So I'm thinking that the material under section 4.5, I'll take that page and the next page, which also has a table 4.5 and a bit of it in the other page. If you find it so comfortably in the picture or maybe introduction, so that we just focus on the result of that objective. So again, that goes back to focusing on the work. And the statement there, give the hydrogen. That is under section 4.5.1, below the table 4.6. The statement there, based on the results presented in the table 4.5, the second sentence says, the results of the 5 of the 8 sets will then high correlation coefficient values greater than 0.95. Do you note the part of this sentence? Greater than 0.95. And you know what greater than means. Oh, so 9.5 may not be bad. If my understanding is 0.95 may not be bad. But we look at the table, there are two that have. So it's a small thing, but
It's not the case.
take note of that.
Yeah.
Overall, for this section, I think I'll put it CPRA that you need to organize. Just like I informed you about that. This is a discussion. I want to see, as part of organizing the chapter on research and discussion, we will have a summary of the developed algorithm at the end of each relevant section. By that I mean, because when I read research and discussion, I want to see, yes, it's the result, these are my thoughts about it, and once you're done with that, at the bottom there, I want to see maybe one paragraph that summarizes that model that is back. I know you will have it in the conclusions, but let's have it, let's conclusion number 1, at the bottom there, number 2, at the bottom there, so we need to have, so that we appreciate. Because right now some people actually look at this work and fail to understand what the algorithm was proposed, what the algorithm developed. Because there's so much information. So you need to take the reader down to now appreciating what all that one means. By putting something that we look at and know that yes, this work that has been done. And this is the package. So in conclusion and recommendations, there is a last paragraph. When you look at the conclusions that we made on the slides, they are well stated. And when you look at the conclusion here, the paragraphs are too lengthy. Now it is a paragraph that has so many figures and even the reader loses track of the sentence because he's intimidated by these percentage figures, so many. So I think you need to refocus the conclusion. But you need to balance, because now what you stated is very well written, but the content is not as much. But in the cases you want to have a little more content, so you need to balance between what you presented here. You take what the good part of what you presented in the slides, and then the good part of it, so that you have something that someone can read and say, these are the conclusions, and appreciate. As part of the recommendations, because you said the recommendations, I think you didn't really spend time to look at what needs to be recommended, what needs to be recommended, especially part of other work. I think you need to discuss that. But from what the work you've done, I want to see, because when you look at the 2-parameter and the 3-parameter meteorological parameters, you look at those tables, you realize that where you have high correlation coefficients, 0.8, 0.9, where you have sunshine hours and maybe maximum temperature, then it falls short for relative humidity, rainfall, and so on. I want to see some work where researchers would explore improvement of what you've done, so that the areas are less, so that those parameters that are falling short here are improved in terms of output. So it would be nice to improve what you've done in terms of improving the accuracy of the parameters where the models where you had more than 2 or more than 1 parameter. So I have to see something. So if you can package that recommendation again there, I think it will be a good thing. Here, as I wind up, the general comments. There are general comments just as part of the improvement of the document. One is that when you look at the document where we have figures and tables, at times I was mistaking the captions with the text. So I think you need to separate that. Not just leaving a gap, but I think you can as well have the caption in italic. The emphasis. So you can have the caption in italic. And I also observed that some equations, I think most of the equations have a comma. You know, that's, I'm not used to that. A comma in an equation and then an equation number at the end. feels a bit, I'm uncomfortable with it, but you can make inquiries about that, whether you need to have a comma at the end of the equation, because there are commas at the end of the equation also. And then I was also uncomfortable with the where you have ranges. You have 0.9 dash, maybe 0.96, 6.5 dash 10 to define a range. I think we're better off using set to the range, this to this, this to this, because the very stubborn person will think that that dash is a negative, maybe a negative of the number. So if acceptable, you could use the 2 dash to that, this to that, this to that. And all the equations should be numbered. There are some equations, I know because they are so tiny, very small equation, tiny in the text that there are few parameters, so you are hiding them within text. I think there are about 2 or 3. So each and every equation that is in the thesis should be numbered for ease of reference. And in the future, because some of us who looked at this were denied review of the data set. Yes, you said so much about data and presenting the results, but some people may want to look at the data set that you use just to be sure. We were denied that. Some people feel that it shouldn't be, you have a lot of data and shouldn't be in the places, but you can have it in the appendices. You have it in the appendices. But all, if you can't have the entire data set, at least something that you can package and have that data. So in future, I think this goes to the higher offices that we should emphasize the inclusion of key data sets in the dissertation thesis for ease of reference by reviewers and examiners. And they can be included in the appendix section. We took time deliberating over that table that where you're saying giving reason clouding, and then for me I think it's some errors. So if we had a data set in appendices, it would be very easy to make reference to that and check that out. And lastly, abstract was written like it's a paper. For the paper, will probably have just 1 paragraph. I don't know that the standard university accepts breaking it down to paragraphs, because normally in dissertation thesis, the abstract, the executive summary is a little extended. So if the university accepts, I would rather have it broken into paragraphs for easy to flow. But I know for paper, normally it's like 1 paragraph. So I thought I would share that with you. And having said that, I take this opportunity to thank and thank the Dr. Ward and the team for giving me this opportunity to travel with Walter. And overall, I think we need to do a reorganization of the document. The results are there, the materials there, but just reorganizing it and also paying attention to detail. So there are some few grammatic that can be corrected. But I wish you all the best, and back to you, Dr.
Thank you very much, Dr. Muyo, for that very exhaustive engagement. We always welcome that because greatly improves the quality of the work that our candidates undertake. So thank you so much for your time and process to ensure that this is meets the quality that Makerere requires of us. Okay, so let's move on to the next stage of this process, which is an engagement with Viva Bosse Committee. Before we come on board the technical issue, I have 2 sets of general issues to point out. The first one is for the completeness of the work to ensure that it meets our requirements. And then second, I just have the 3 observations that may require your attention. So the first one is, as mentioned by the discussant, the abstract. We normally require that the abstract fits into one page. Yeah, so the, whether it's difficult to end paragraphing because then you probably miss out on a bit of space. But you can structure it in such a way that different elements are separated somewhere, but they should fit into one page. The other issue concerns the background. The background should be focused because it's quite lengthy. So we are really bringing out the rationale of the study, so that that's the key elements that we need to see addressed in the background, so that you don't over-elaborate on what should be there. 3, the specific objective. There are smart verbs. You know, there are so many smart verbs from Bloom's taxonomy. So don't use the same smart verbs for different specific objectives. And we normally require those to follow different depth or different level of intensity in terms of what they address. So that should be very clear. The fourth one concerns justification. The justification is too limited. Does not bring out, does not really give us an exhaustive reason why this is important, why the approaches are important. That should come out very clear, so that we appreciate that this is a methodology which will make a difference. Okay, so that's, and then scope. Scope, again, is also lacking in certain respects. Scope should be very factual, either spatially, parameter-wise, temporal terms, time-related, applicability of the aspects, and so on. And I'll come to that in a moment, because one of my comments was against the scope. And then with the literature review, again, the citing of differences, we expect that to be very well balanced. Not write a paragraph and then cite somewhere in the middle or around the end of the paragraph, because then that means that you're not making use of the resources that others have already put forward. Okay, so this is a review of other people's works, and appreciate them, make sure that they stand out, so that it's easy to see that this one has made that contribution and so on, and therefore, because the basis for this is we're trying to see how the specific objectives have been addressed before, and where, as we discussed, I'm saying, are the gaps. Okay, so that should come out very clear. The next one is the map of the study area. It's not enough for you to stand there and tell me the other station is over there, the other one is in physics there. Now, if I'm in Nakulabide, then I have a problem finding where your stations are. So you need a map of the study area. So here they're showing this is where the study area, all these attributes. So in this day and age, maps are very easy to come by, and it should be included in there. And then there are small things like when you're referring to figures or tables, you need, the first time you refer to them, it should be before where they're initially placed. Because I was skimming through and just not some of them are out of place. So make sure that your reference to figures, tables, whatever it is, initially come out before where they are placed. Because that then clearly places it. And then the results and discussion chapter, I have mentioned this, but you need to be very careful about the results and discussion chapter if you combine them, because it brings issues. So if you don't, you have to carefully present your results before you discuss them. Don't just plug figures or tables there and then start talking about how it relates with others. Tell us what are the key messages that are coming out of that figure, out of that table, before you give your opinions or how it relates with others. Very exhaustively and very focused way. So that comes. So this is why most students separate the two. The moment you combine them, be very, very careful. Otherwise, it's going to give you a lot of problems. So make sure the presentation is very, very clear for each of them. Anything you put in there before you discuss them. And then second last leg, again, as I mentioned at the beginning, it showed very well in your conclusions coming from this perspective. So it should be very clear. We normally require of that. But in the book, as the discussant said, tied around there. Whatever you do, showing us that you have made a contribution there. And then lastly, listing references. We normally require one style. It's very, very clear in the handbook. And we choose what we prefer and consistently use each and every reference. Don't have one listed this way, and then the second one you probably decide I'm not going to include all the names, and then the other ones I include and so on. That consistency is something we need. Okay, so those are the general ones. So let me comment on three things that I noted specifically. One is I was looking at the title, specific objectives, scope. So I was relating those three. And I know the title is very clear. You're retrieving your parameters, meteorological parameters, using a very clear approach. When you started presenting, you tell us, you show us so many studies have been done. And you're very, very clear. Yours responds to terrestrial areas in sub-Saharan region. I noted that. And then I go back to the title and say, how focused does the title? Because it's not big, it's working on marine areas, not working on this, but all the other areas. So you need to think about that. Is that title appropriate for what the focus of the area that you're, or the scope that your study is dealing with? You need to be very careful there, because otherwise, reading that, I would think this would be applicable anywhere under any conditions, which is not true, as you rightly say. So think about the geographical scope of that title, because otherwise, and that stems from, and this was the other issue, stems from the gaps. Because you listed so many who have done work that I struggled to see where, what was missing, or how related they are to your area, and therefore what you may be right, which you're contributing to. Yeah, so that should come up very clearly. So I look at the scope, and I see 5 parameters. Now, when I got the specific objectives, the first specific objective focuses on one parameter. And then the other 2 is retrieving 2 and then 3 of those parameters. So how do you decide on 2 or 3 if you have not exhaustively retrieved each of the 5 parameters? Unless you are saying the first parameter is an independent variable, sunshine hours, and the others are dependent on that, which would also require those specific objectives to be accordingly focused. Okay. So I struggled with that. Why are you putting 3 parameters when you have not determined that one of them can be done? Or for that matter, why should I put 5 parameters rather than focusing on 2 or 3 that I have selected using a certain criteria? Okay. And whatever you're going to write there, I should see it in the specific objectives. Whatever follows, I should see it in the specific objectives. So that's the basis of our specific objectives. Okay. So I think that I struggle with that. And then when I come to the last one, where the applicability. We have used the data sets from Makerere to train and validate the model. Why don't you go to Cabanyolo? You very clearly told us one support agriculture. Go to Cabanyolo, they have a station, the weather station, I think, and use their data sets to compare with your retrieval of the parameters around there. And then I will appreciate this thing works. And works in a similar environment as we clearly say under sub-Saharan African conditions. So those are comments, don't worry, I'm just thinking aloud. Okay, thank you. Let's move on to Dr. Michele, please. Go on.
Okay, so thanks for the opportunity. I also begin by thanking Mr. NZALA for a good presentation. I just have a few things really and I'll also be very quick. There are few and I'll try to be very quick. So I have been asking myself from the very start, if this was conducted as a PhD of computer science, I and so many other people in this room would accept this fits to be a PhD in computer science. Would you object?
Doctor, we also have instrumentation in physics, where we're interested in measuring quantities. And this is an application for ICT and software techniques to instrumentation.
So, sincerely, feel like if we are categorized these PhDs, we'll give you a PhD in physics instrumentation. Okay. Yeah, so if I ask something and if you don't have an answer, you can clearly say, I don't know. And we move on in the interest of time. And those first two questions of mine stem from something that I've seen is missing throughout the write-up. The idea is, according to me, we've been working on solar energy, but as you can also attest, you steered away from really aligning yourself to solar energy, which is pure physics. I got a definition in senior one that physics is the study of matter in relation to energy. So I have been looking for your energy. I kept on looking here and there, and I couldn't see it. So now I'll drive you to areas where this could have been incorporated, but you steered away. That's why I'll give you a PhD in computer science, not in physics. So you would have qualified for the one of physics if you had answered the following questions. So you have been inputting things and training your model, at least forward. And then you have these things you called, most of the people in your line have been calling them transfer functions. So this time I think you chose to go more specific, call them the radio-based functions. What informs your choice for a given radio-based function? Not physics. Not the physics of the problem.
Compare the use of scholars in physics who have used these activation transfer functions and their comments about them, the advantages. That's what drove me to the choice of radio-based functions.
You see, Mr. NZALA, this is a PhD. If I were you, apart from looking at what people have done, you imagine if you had gone on to understand the physics of the problem. And the question in this line is, imagine you had a data point which was way off, and then you had the courage, that was very good. You went on, you clustered the data to investigate why this particular point went away. I want to believe you gave some explanation which is wrong. For me, this was the physics of the problem. Unfortunately for you, thought maybe it is something, it is the physics of the problem. So we usually have these, we call them extreme events. You mentioned something about them in the background. We have extreme events, very difficult to predict. They are so difficult to predict to an extent that when you met it, what usually people do is they throw things away. They discuss and I said, no, just present for us the data set, we shall know what to do with it. So from your model, it was always clear extreme events were going to be a problem. Why? You train. So we train a model with the understanding that it would learn that every time it is January, please just understand that there is a lot of sunshine. But when it is these months, please remember that there is a little sunshine. And then you tell you, okay, did you learn? And then you give it some data and say, okay, according to this, it learned. You can give a mark which you call the correlation coefficient. Is that correct? Is that a clear? Is that a good summary of what artificial neural networks do? The answer is a simple yes or no.
It is not only the correlation coefficient, but plus all other statistical tools. When they are good, we take the
You give a mark. Good. Now, what if something that was not in the training data set occurs? In the past few years, Professor Senyonga with another student investigated the occurrence of heat waves. Rare event does not happen. So if you train the data set and then it finds this new thing, what happens?
Well, it may not predict it well enough.
Okay. So when you wrote about prediction of extreme events, I saw a problem. You will check in your introduction that that thing is there. However, I always argue for people who train networks and tell them to reproduce what they have trained, they should never talk about extreme events. Because they are rare. They are things that we have not seen before. Isn't that correct? Which clearly puts you out from the SDGs. Because for them, they tell us we have the particular SDG we pointed out says we should be able to predict extreme events, but artificial neural networks are not designed to do this.
Doctor, one of the things artificial neural networks do, robust is that it can incorporate noise and make sense out of it if the learning is good enough. So with extreme weather events, and that's why in this research we apply unlimited. The function is not limited in a particular range. The issue was to enable the optimization function, where possible, to recognize extreme events, because it's unlimited. But I also appreciate that it may not be easy. So the prediction of extreme events may not be done as accurately, but there will be some limitations in that direction.
In which case, that would mean that probably your training was not sufficient.
Well, the data was limited, and
if you train a kid, this every time it is 2 o'clock, we take tea. When it is 3 o'clock, we don't eat. And then something very rare happens that this person is eating at the time you refuse. That person didn't learn. I think for me that would be the basis. If you ever picked an extreme event, it would mean your model didn't learn enough. I think so. Okay. Maybe that is, I know you're going to answer the next one clearer. So, if really things had gone well, you run your model, things, you forward train, and then you go the other side and you produce things backward. In physics, we have a causation. So when something really happens, we should be able to attribute it to something, one-to-one. That is the basis of Newtonian mechanics. Definition of a force, if anything ever moves, it is because something pushed it, and then we give that a force. In the framework of artificial neural networks, if you can have so many inputs, and then they lead to just one output, the moment you try to go backward and you have more than one output coming from one single thing, I would want you to explain to me that. Knowing physics, if you were to discuss statistical mechanics, you think about it. You start with something very organized, and then all of a sudden, the thing is so disorganized that it is giving you 4 outputs. I don't know what this really means.
yes, it is learning outside of the box. It is learning of the artificial neural networks and it is the artificial intelligence because it has been reported by some scholars of neural networks and meteorological algorithms, parameters in that way. And that's why we have the training methods are not so deterministic, so that you know that always this produces that. But in the process and in the body of a large amount of data, the neural network recognizes some which are directly linked and also recognizes a certain trends that can lead to a change in the relationships. And it uses that to predict fuzzy data.
So, sir, sounds as if it is correct, but it isn't, because of violent physics. In physics, if I started with a system and it is in a state so that I can measure the entropy, which is a measure of how disorganized it is, in your case, there's so many inputs or outputs. I should be able to quantify why it has morphed into just one thing. I mean, if you had the questions, I would have told you, we could explain really. For example, if it is sunshine hours, maybe relative humidity, someone can explain really that probably these things are run by the same dynamic. For example, if you give me vapor pressure, relative humidity, I can tell you all those things are driven by wind. So just one thing could be causing all of them. In your case, you chose to steer away from the physics. I still argue, for me, that is the cause of all these. If you had gone and chosen, say, a transfer function, which behaves in a certain way that mimics the physics of the problem. In the current case, what you do is you say, for this set, sunshine hours, relative humidity, and maximum temperature agrees. But this other set, sunshine hours, maybe pressure, and this one does not. And for me, all those are pointing to one thing. Probably the physics of those other three parameters is something different. These ones are also having a different dynamic. So if I were you and I wanted to do these things again, to incorporate the physics, where do you think in your model is the right place to attack?
We look at artificial neural networks and inverse artificial neural networks in terms of mimicking the functionality of the biological neuron, of the brain. In the brain of a human being, there are many things a brain can figure out, things that the person has never seen, and that's why human beings go to the level of dreaming and imagining. The predictions are not always deterministic. The predictions and the thinking of the brain can bring something out of the normal. And that's what the construction and working of the artificial neural network and the inverse artificial neural networks attempts to do, to use, and to improve on.
Yeah, Mr. NZALA, it sounds as if it is correct, but it is not. Some things about the brain are deterministic because you have chosen to go biology. If a lion came in here, I can tell you I can predict 90%. Everyone in this room would not remain in their sleep. Deterministically, I can tell you that is the truth. So while in some precepts there is a range, but still there are things we should be able to tell. That said, you have not answered my question. Where do you think, if I wanted, for example, to improve the correlations for most of those plots, where do you think we could go and what could we have done better?
To improve the correlations, the name bias. One of the things in this method of predictions is to have larger data sets so that there is more learning by the artificial neural networks algorithms that can incorporate the deterministic, recognize the deterministic relations, and also recognize the relations which are not deterministic. With more data set, artificial neural networks have been reported
closed this door? It's usually the question I ask people who do artificial neural networks. How really effective was your training? In your case, you said you trained with 90% of the data set. For me, as if it is even overtraining. Isn't it? You imagine this parent who says, I want to train my kid before I die, so that they will be able to cope in the future. And then you choose to take them through everything they are likely to go through. For me, this is not training. You're telling them, I don't know which other name I should give it, but training someone to be dynamic is a different thing, which I think should be the idea of a model. For you, you already trained with 90%. I think that door is already closed. The training is effective, at least in terms of how long your series work, the training was. What else would you really do? You look at this problem here. I don't believe in that particular sect that you exhausted everything that you had. I can drive you home. This is a PhD, sir. Bear with me. And if it is going to be your physics, we better check really. Imagine if I knew that Uganda is so prone to cloud cover. And then I gotta get the data for cloud cover, get the probability distribution function, and then I project my data onto that probability distribution function so that it picks the fact that I already have information about cloud cover. Before I even input it into the model, don't you think that would have worked better? What would you comment?
Well, it works better for situations where a relation is well defined. Now, cloud cover and the way clouds attenuate solar radiation is one of the areas where deterministic relations are not easily constructed. And this is where we explore this way to get data that would otherwise be got using instruments that physicists use to get information about quantities through a non-deterministic method, a method of prediction, a method of artificial intelligence. It is application because I've also seen before that there is what we call computational physics, in which we are bringing in as much of ICT, as much of software, and as much of artificial intelligence in obtaining information. I've also read that of recent, in chemistry, the Nobel Peace Prize winners were scientists who apply artificial intelligence techniques.
It's physics.
You are happy with physics.
It is in physics.
Yes.
Then physics can incorporate artificial intelligence.
For me, my only issue is, if I have prior information, I should be able to use it to refine my findings. Here, I deeply believe, Mr. NZALA, you could have done something if I know something is coming. And that is the point that Professor Wall was trying to bring about. Now, your results are going to be tied to a point. In research, we said they are not that much robust. Okay? Yet, if you had gone and said, you know what, every time you're in a location where the cloud cover behaves like this is always true. That's how research becomes more credible, because your findings are very robust. In this case, you denied us of that. Okay? One last one before I go. So you chose, I think, 47 as the number of neurons to use.
It was after investigation.
It was after. Exactly, that is good. Although you didn't write that explicitly, but still I would want to ask, why do you think 47 worked?
with artificial intelligence, at times things, the learning occurs at a particular level. Just like the learning and intelligence within human beings, they will be very the same, even those from the same family. And so, the justification of a particular neuron number, and that's why we get iteratively. The investigation may not have a specific relation, but it just happens that at that level, and through the training, the neural network was able to understand that data to a good extent, and then we adopted that. If we freeze it at that level, then we continue to freeze it at that level for similar conditions.
So if I would ask, so if someone used the 50, do you think results are going to be better or worse?
I actually used 50 as well, and it was not good enough. I investigated so many neural numbers. That's why, and then picked one for which the results in both in the feed forward, because the final conclusion, the final decision was taken after running the whole way to the inverse artificial neural network. Even if a neural structure, an architecture in the feed forward performed well, but it did not perform so well in the retrieval process, it was dropped. It was seeking for that which worked well in the feed forward and also worked well in the eye. In fact, there are also some architectures which were not the best performing in the feed forward, but performed reasonably better than the others which performed so well in the eye. And those ones were adopted because the final target was to be able to retrieve. That level of learning of the artificial neural network is good enough for the purposes of retrieval of the parameters.
Okay, so again, you have just busted my mind. So you have a system that has a cusp. Okay? Go past 47, performance goes down. Before 47, performance goes down. So something is unique with 47 for your particular model.
And it is not exactly good. There are also local minimum, local maximum, then local minimum, global maximum.
But this one was a global one, at least for your study.
Yes, the 47 is a global one.
So I would be happy if you had, I wish you had included a graph showing the number of neurons used, and then probably the root mean square error, okay? And then you show it, and then you say, for that reason, we chose to use 47 neurons in whatever is going to come below. You see that the process you went through should be documented there.
It is reported there.
I didn't see the graph.
You came up with the 47.
Mister, I didn't see the graph.
No, the graph was not on the
I was very critical about those things because they inform science. You realize that I keep on asking, why did you choose that method? So the only way you could qualify the 47 you used is if you had a graph like that. So you report both the things that you have not shown, okay, and then the one that you went on to do in detail. That would be good writing. It would greatly improve the quality of the book. Okay? In fact, that is what entails in optimization. So in certain things, somehow the performance of your model is optimal. And the way it looks, your study was optimization.
Yes, it was optimization, but eventually we had graphs which were, after considering all the various parameters, not one, all the various statistical parameters, and then we come up with graphs which talk about, like this is the one of this one here is the one of the 47. This is the graph which comes up to show the best performance.
Yeah, I don't like that graph. That graph is not the one I mean. I mean the graph that shows number of neurons used and then set the root mean square error. Okay? The thing you went through, you said, I worked with a few of them, I even reached 50, but then I realized that 47. You know that graph, they're having a peak at 47. So it comes, maybe it rises, you could do all things of alternating, but at 47 it shows a global maximum, and then in a paragraph you say, because I realize my model is optimal at had 47 neurons. From now and onward, we consider 47 neurons. That is good writing.
It is true. There were cases where the one which performed best in the 47 was also the best in the retrieval. But there were also cases where the one which performed best was not the best in the reverse process.
Yeah, but then if that is true, then probably there were also a case where the retrieval was very good, but then the training is very bad. Because you're saying your system was doing all those things. And because your title is retrieval, for me, you should have taken the one which gave you maximum coming backward.
Yes.
And then you leave the other one for other people who will choose to concentrate on the forward one. Think about it. One last one, I'm about to go. How do I therefore use your findings? One, they are not one-to-one. So someone could use that same model and produce those results. So this is the equivalence of, say, Civil Aviation Authority giving you a contract to tell them what the weather will be tomorrow, and then you give them a certain number, and then someone else does the same thing for a different region and gets the same thing. Imagine if you were the one and you look at two different weather patterns predicted by models, but things are the same.
Yes.
Would you feel okay?
The non-uniqueness of models is a fact that should not be a disadvantage, should not be discouraged. So physicists and people in modeling have treated the non-uniqueness as what the limiting factor, because once the model produces acceptable results, whether other models also perform well, it wouldn't be bad. In fact, it's not bad to be able to determine values of meteorological parameters accurately with different methods, because otherwise, and different models, otherwise, it gives us leverage, gives us advantage, gives us choice according to situations and limitations of the investigator.
For me, Mr. NZALA, this is how I interpret the situation. If I start with something but then my results could be different, I interpret that as a scenario where I won't be able to predict. Sir, you think about it. If I was solving a Newtonian system, I start with the differential equation. If I don't specify initial conditions, I'm likely to get as many solutions as I want. Not predictable. However, if I wanted to go deterministic, consider the case of Kampala, Makerere University alone, I would put in the conditions of this area. Then the model should give me things that attribute to only this area.
That is predictability.
That's what they call predictability. Then, in this case, I don't think we have that, sir.
But we accept that in prediction and in application of models, the prediction knowledge is not always 100% accurate. And that's why we have levels. That's why there may be some outliers, but the general trends of the information, of the parameters over time is of value to climate change, understanding climate change, and it informs. So, whereas in the process of prediction, yes, some values may not be predicted accurately. In fact, there will also be some outliers. But when you talk about correlation coefficient being equal to 93, it means a large number of the predictions are good enough for use in a number of applications.
Okay. So if you were given a chance to redo this study, what would you have done differently? What would you consider as the most outright revelation that you have come to know now that you didn't know at the start of the PhD?
Artificial neural networks?
on this project?
Well, this project is about artificial intelligence.
Yeah, so according to you,
What I've done over time is that they can be helpful in getting us data for some theme applications, for following trends, and to do different trends, as some of the things are put in the recommendation, we need more training data sets, and also more data from different localities, and also testing in different localities. Those are things.
which will be a test for robustness.
Yes.
Check if it works elsewhere.
Yes.
Also train with other data sets and check.
Yes.
Otherwise,
Yes, the limitation, doctor, is that there are several stations with incomplete, with data which has so many gaps that even when you want to say, let's also pick this data and train it, this training has those challenges. Equipment, we will have malfunctioned and have been left for, there will be some challenge without repair. And that's why, where we get data sets that are more or less matching a good amount of versatility, we use that to train. The other areas, we shall use them with expanding. In a research like this, they always room to expand and do more.
Chair is having
Dr. Howard is on.
Thank you
Very much.
Thank you, Chair. And thank you, Nicholas, for the presentation. I have very few questions. I won't take so much of your time. And hopefully I will not vex you as much. I'll begin with what is connected to what Dr. Uche is saying. The importance of you showing us, or proving to us that these were indeed global maximum, okay? Or global minima, depending on what direction you're looking at it from. It would be very important for you to include that in your report. In your report, all you talk about is you say you chose the number of neurons that gave you the highest correlation coefficient.
And you would be bias and you will do positive, absolute positive, and also do root mean square error. That's what appears on those parameters, all taken into consideration.
That appears in the table, but when you were qualifying for why you chose the number of neurons you chose, you only mentioned correlation coefficient. And that perhaps wouldn't bother me so much if you had not gone further on page, sorry, I think it is in section 4.4. On page 74. So if you go past section 4.3.4, that's page 73, then on the very next page, the last line of the first paragraph.
That's 4.4?
4.3.4.
4.3.
Now go to the next page. That's top paragraph, the very last line. Let's say the last two lines.
Last paragraph.
The top paragraph. Okay? So the last line of that first paragraph, the last two lines. You say, according to a square of the term, correlation coefficient falls when the range of values is reduced. Okay? And I'll come back to that later in my last question. And then you say, this implies that correlation coefficient is not the appropriate performance analysis tool for this type of categorization. You depend on it to choose the optimal number of neurons, but then you contradict yourself and you say it is not appropriate. You need to revisit that. And this stood out specifically because in each and every objective that you listed in your results, you put correlation coefficient on a pedestal after having made this statement.
is your voice? As far as this subject is concerned, what is the voice of this researcher? But if this researcher is contradicting themselves within their own work, if you would like to, if you found something, okay, that is contrary to what you found before, you can publish two separate articles and say, this is what we have, this is what we have. But a thesis is your line of hypothesis. It's something you're giving us your voice. This is my opinion. Okay. So please take note of that. But yes, include the graph that justifies why you chose the number of mirrors that you chose. And not just for your own, not just to make your voice heard or to make your work robust, but remember scientific work is supposed to be reproducible to a certain extent. That's also why you were told to present your data in the appendix. Someone should look at your work. They do not have to necessarily get the exact same results, but if they follow the procedures that you follow, how are they going to follow them? By you giving the detailed explanation of why you did what you did and how you did. If they follow those procedures, they should be getting results that agree with their results to a certain extent. Okay. But they will not be able to do that. Why? Because you leave out information. Key information. Okay. So that is very key information. Please include it and remove contradictions to yourself.
Yes, doctor, is yes, it's a contradiction, but I thought I was making an observation that this, when one has a data set, I think to divide it into categories, then the correlation coefficient is affected. Not that really it is a bad thing. If the data is not categorized, the correlation coefficient is false.
But remember, you categorized it simply because you wanted to explain why before that it was generally low with the larger range. I would suggest you explain to us. I guess this goes back to the physics. Why do you think for these particular conditions the model is behaving like this? Don't just say, oh, you see we have a narrow range, so correlation coefficient is not giving us what we want. Then find what will give us what we want to find out. You get it?
Yes.
Again, to tie in with sort of ties in with what Paul was talking about. So if I understand it properly, okay, you have several data sets, sunshine hours, maximum temperature, relative humidity, etc. Okay? These have been measured, right?
Yes.
You get 90% of that data, okay? Put it in a feed forward. It develops the neurons, gives you the solar radiation. Okay? You compare that to the data of solar radiation that you have to see if it's making the correct predictions. Am I correct?
Yes.
Then, in the inverse step, you feed in the predicted solar radiation values or the measured solar radiation values?
And see, that means you have a data set, say of 100 data points. Get 90 of them. And leave the other 10. The other 10 should not participate in the training. The 90 of the 100 are used in the training until the neural network lands. Then you say, okay, does it land? Yes. Then the test uses this other.
Also, the test is still done on the forward part. The testing is done on the forward part. 90% you train to get solar radiation on the forward part, okay? Then you get 10%, you feed it in, and you get solar radiation again, right?
No. The 90% is used in the training of the feed forward artificial neural network, whereby you feed in, say, sunshine hours to get solar radiation. That process is done at a hospital as possible. That training, yes, we test it to see that the neural network ability tries to run as much as possible over the relationship. Then, that neural network is frozen. This number of neurons in the hidden layer at this level of the spread in the clusters, it performs well. Then we answer that if it is performing well enough, yes, let us use this new data of a similar time in a similar environment.
Which is the other 10%.
The other 10%. It is now used in the inverse testing to retrieve parameters.
Okay. So that means this is quite interesting. So, in order for your inverse and to work, there has to be measured parameters for everything. And yet, in your work, you want us to be able to apply this ANI where you don't have necessarily all the parameters measured. You get? Am I correct?
Yes. But now, can I explain? Yes. The ANI needs measured data to train and learn the relationships between horizontal parameters, say sunshine hours and maximum temperature, and solar radiation. Once it has learned and tested within the same area, the other 10%, then we know that ANI can work. It can now retrieve sunshine hours maximum temperature from any other new data in localities of similar conditions.
Have you shown that in your work? Different localities?
Yeah?
Different localities of similar conditions?
Because of lack of some of the data in most of the localities, but we said, doctor, that this has been area for
That would be the validation for your work.
The validation we did was with the different thresholds. But then that one, we're going to look out more, but remember between some areas like the Boardroom, National Weather Station, and the Sierra, they did have the solar radiation data. So the testing can be done for those localities.
So the different studies that you cited in your work that used feed-forward methods, when they did their testing, when they tested their models, they trained with 90% and then they tested with 10%. They still tested their feed-forward steps, right?
Yes.
But you didn't test your feed-forward, you tested that.
It was tested. Well,
There's something I'm not getting there. That is like a two-in-one question. You trained your feed-forward algorithm, okay? You flipped it on its head, and you did the testing on the flipped part of the algorithm. But I would think a complete development of the AN model requires you to first test it before you freeze it. You freeze it. You said you froze it.
the feed forward is trained, is tested, and is then saved as shown in the conceptual framework. And then we use that feed forward on new data, and it retrieves it.
Okay, where did the new data come from? Because from your previous explanation, the inverse only dealt with the other 10%. If I remember correct, what you are saying.
Yes, the 10% is not involved in the training process, but is involved in the testing and also in the validation of the line, because it was not involved in the training.
Okay, try to make that clear in your program. My next question is when you chose the Gaussian RBF, okay, you say that it was found to be more stable. I'm sure you got that statement from the literature. But please explain what is meant by it was found to be more stable. Because those of us that are reading your work, we are not reading that other literature that you read. So explain what you mean by it was found to be more stable. And the stability, is it dependent on the type, the kind of data that you're looking at, the locality you're looking at? What is that stability? Is it affected by certain issues that might make your data distinct from other people's data? Yeah.
Yes, stability in this case.
I'm simply saying, include that explanation in your thesis, yes.
Thank you.
And your explanation of the Nelda-Mead algorithm, first of all, I don't think I saw it in the thesis. If I saw it, it was quite insufficient. And here you tried to go in detail, but it was quite, in my opinion, it was insufficient. I didn't learn anything about it. If I had come here to understand how did that algorithm help him in this one, and you say it is the center of gravity. That explanation is quite insufficient. If it is that important to your work, please do something about that explanation. That's just a comment. That was not a proper explanation. Make sure you include it in your work. You mentioned that the mean bias, that is the MNB, reflects long-time performance of the model, while the RMSE reflects short-term performance of the model. When you're speaking with people that have used those things on a continuous basis, they can let it pass. Okay? But this is your, how do I call it? Your thesis is your masterpiece. You don't just make random statements and move on. Explain why they might say this is this. Because these are your performance analysis tools, right? Yeah. And then on slide 45, this is just basically an example of something that happened throughout the book, from what I noticed. You did not attempt to explain. You can go to slide 45. Is it slide 45? 35? The slide where you had the rainfall parameter having a very high marking. It was a tip. Just keep going back. I think it had 200 and something.
Yes.
Yeah, slide 34. Okay, I added one to each. So, you can see 255 is, if we call it an outlier, would even be undermining the word outlier. That is outrageous. Okay? But no attempt at explanation was made. Okay? You just said that's how it is, I'm moving on. This is clearly showing you there's something going on in there. Maybe in the way you, perhaps the optimization could have been different, maybe the function you could have used could have been different. I don't know, but try to explain. I don't find any discussion of these things in your...
Talked about grounded days. I also talked about rainfall days. But rainfall and grounded days are close to each other. They make the performance of this model not so good. This is an area where the model did not perform well. And that's why we need to think about it. But I feel it is as a reality of a research that you can get the model working in for some parameters quite well. And that's what we check, that's what we use. It may not work for certain parameters like gravity and rainfall. And yes, when you get like this one, then it will not be used for that particular case. And that's where it is part of the recommendations. There is need to try and find, to do more work to try and see how we can get better performance results from there.
So, would you please just, in your results and discussion chapter, whenever you present the results, don't just tell us which is basically what you did for that chapter. Tell us, we get this number for this, we get this number for this, this is high, this is low, but how you attempted to explain to me now, try to do that again, okay? Try to explain to us, because that is the whole point of your thesis. Anyone can go and plug numbers into MATLAB and give us results. Okay. What sets you apart is what you're deriving from this and what you want to drive home. Okay. My last question is on slide 39. 39? Yeah. So the far left plot. That's figure A.
Yes.
Yes, figure A. We are having a correlation coefficient. First of all, explain to us the fits. The dashed line and the solid lines. What do they present?
The dashed lines is the one-to-one.
Is the one-to-one?
That means that is the line on which the points would lie. If the model was ideal, was doing 100% accurate prediction. Yes. The other line is a line that is used to calculate the mean square and the mean height. We have a fit line to the data, and by calculation is able to tell us the error differences between the ideal line and the data.
So the other line is the fit line to the data.
Yeah.
In figure A, when you visually inspect that plot, does that line represent a sensible fit to that data?
Yes, the multiplier function used to be brought like this. Represents that line that way, but in actual sense, it is trying to give the impressions of an alignment of the correlation between those points. And those points, as they lie there could be a roughly good line that can be drawn through them, showing some kind of linear relation, although it is not along the ideal line of performance. So it is a calculation represented in that graph, which informs about the nature of deviation of a line that this data will fall on.
So, you believe that fit, that is a good fit?
The calculation shows the correlation slope of 73, and the fit shows a line can be drawn, but not along these ones. So this other line of fitness is calculated by the MATLAB function in relation to the line of fitness. It's a calculation, and that's what.
Yes. So it's not necessarily a line of best fit?
Yeah, but it's showing some relationship of the parameters and the errors.
That is a very poor fit. That's all I can say. You cannot present that to us and tell us that line is representative of that data. If we were to calculate a goodness of fit on that, it would fall short. Very, very short compared to these others that even look noisy. Just a comment.
I think that's noted. Mr. NZALA, this is still here. It's issues that are falling short. Let's make this I myself don't agree that in my openness. Yes, I don't. So please, when something is anomalous, please let's take it about it. Please.
Yes. Thank you so much, Mr. NZALA. So So I'd like you to take that, this is just something, whatever I say, it's something which is meant to help you, okay? There's no battle here, okay? First of all, I'll begin from your presentations, okay? The background was so good, and this was also the same in the thesis, okay? I expected different background context, in particular, the context of background, which kind of brings to the major, okay, your title, okay? So for example, you really need to capture the rationale, okay? I saw a lot of stuff, for example, you started, pouring a lot of relevant stuff and so on. I really encourage you to narrow it down, really focus, okay, into the aspect which really adds weight to your main title, okay? Is that okay? Okay, good. Now, let's begin with science. Again, I was really pretty much unhappy with, the paucity of physics, okay? I mean, this is PhD in physics, okay? Dr. Muchibi, you brought it out, but you didn't answer properly. Perhaps this engagement, my engagement with you will kind of clear it. So, one way where physics can enter into your research, okay, is this. Perhaps, look, you got solar beam, okay, jetting, okay, from the sun, okay, it passed through the cloud, a lot of stars and so on, okay. Now the question which I would really love you to kind of connect us is, how does, okay, the solar radiation, okay, contribute? What is the physics between solar radiation and rainfall formation? For example, just one, okay. Can you explain that? Does it affect perhaps the cloud density, okay? Does it affect the inflation of cloud? How does that translate into, rainfall formation and so on? Can you explain that?
Actually,
that's where the real physics is.
yes.
Yeah.
Yes, the rainfall formation is like a cycle, where the solar radiation energy influences the amount of evapotranspiration, eventually leading to rainfall. But also, on the other hand, when the rain, a lot of vapor goes up, and clouds are formed, or even just before rain, again, that situation gets a medium that blocks a lot of solar
But
radiation.
you did explain that. That's Lavinia's central focus of everything. Everything really has to be built on that, and you explain all the details. There's a lot of beautiful, detailed questions on that, which really have to bring out clearly. But you just left everything amorphous. Okay, you started talking of things like the incident, angle and so on. Everyone knows that. Why don't you focus on the real physics of everything and make it very concise and detailed? Okay. Now, with that said, okay, again, artificial neural network is much more like a black box. There is a lot which is not known about it. It's like a magic box. Yes. A lot of things happening inside. Okay, and it has been in existence for over 15 years. I mean, it's not very old, but not very recent. Okay,
Yes.
and there's a lot of development, okay, on it. Okay, now in physics, okay, if you just you have a data, okay, then you feed this data into your artificial neural network, okay, it doesn't really add a lot of weight. If I were you, I'll have a physics control, okay, entry into it, okay. Like, look, you have like we just talked about the physics, right? You control the behavior of the artificial neural network by punching in, okay. You got the physics guiding everything, okay, and also you got the data, this thing learning from it, okay. So it's one thing which I will have looked at, okay. So I'm not trying to tell you to add it at this point, okay. I'm trying to really open your head, okay, your perspective, such that perhaps in your discussion you have to discuss. Another beautiful part of manuscript documentation is you must know the weakness, okay, of your work, okay. You bring it up clearly, you discuss it as a caveat, okay, such that when someone reads your work, they have an impression of this person knows what he has done, he knows the limitation of his work, and okay, you get the point? Do you agree? Okay, perfect. Now, again, I wasn't happy with your problem statement. And problem statement is the central engine of everything, okay, innovation, okay? When you are doing some work, it's the problem statement, okay? So again, I really wonder if you have really touched the base with relevant institutions like UNIMA, okay? Is this the major problem they're facing? I don't think so. And that brings me to a question. I wonder, okay, the relative cost of installing solar radiation instrument and simple weather measuring instrument, like rain gauge, wind speed, and so on. Which one is much more expensive?
Installing. But they also have to be maintained. There must also be security.
What about solar measurement instruments?
Yes, they are also expensive. But now we are saying of the whole set, we could work with one. It will reduce the cost. If one can help us to get the data.
So the thing is, they said, you have done some good work, okay, which is okay, okay? But I really don't think you have captured the real fabrics of things. Yeah, it's not the real problem, okay? Like in Kampala, in Uganda, one of the key problems which we face, okay, from weather prediction is, those geographical barriers, the Lake Victorias and so on, okay? They impact a lot of the data stuff, okay? The data prediction accuracy of UNIMA and so on. But I don't think you have really addressed something which is really very key. To my thinking and from my interaction with your document, I've got to realize that actually you were kind of blocked by what has been done, and you simply massaged it, okay, to a level that you don't want to really push yourself against the wall so much. You just massage the work, and you really didn't care about the current context of something and so on. So it's something which we have to really discuss into detail. Okay, I'm not that in the stuff and so on, but that is it. Then my last question is this: I have a lot of comments, okay, but you'll get it from my comments, okay, yeah, from the report and the thesis, okay, I've written there. My last question to you is this, okay, 95% of your references were not from, Tanzania, Science Journal, something like that, which has a very low impact factor of around 0.357. I mean, to me, I'm new here, I'm just 2 years old, but to me, I looked at Makerere as a premium university, okay? And I expected something of outstanding, standard and so on. But now, my question is this: why did you go to low impact journal, okay, among the seed of very good, okay, journal? Why did you go to?
Because I've seen scholars from this university and from this department with their articles.
I just like it, sir.
It's optional. So, okay, thank you. But as I went on. Please, Dr. Robert.
Yes, thank you very much, Chair. I'm going to be brief, aware that I am neither a discussion nor the examiner of the thesis. I'm going to be brief. First of all, I wanted Mr. NZALA to clarify why the conceptual framework should be named NZALA model. What is special there? Wanted me to clarify that. What is special there that it should be named NZALA model?
Can I answer?
Yes.
The conceptual framework can be given any because when I looked around in the literature, I saw that I didn't see a conceptual framework exactly like that. And that just happened to be one of the choices that came my way because it can really be given any other name.
Okay. So you will later change it to role model. Okay, yeah. So I'm not surprised that your abstract occupies 2 pages because the background itself occupies 8 pages. So I think you need to, at this point in time, you need to know how to summarize it. Abstract is actually a summary of the entire thesis, but as the chairperson has guided, it is supposed to be a page is even more. If it can be half a page, it is better. That is just to guide the reader. It's just like highlight of what is in the thesis, but should not take much time of the reader. I'm not surprised. Then inside there, I've noted that there are certain, I either sections or subsections that actually have the same title. For example, when we go to Appendix A, the title there is Published Works. Appendix B, the title is also Published Works. What is the difference? If they are the same thing, I would have loved Appendix to read Published Work, then Appendix A1, Paper 1, Appendix A2, Paper 2. That would be. Then when I looked at the publications attached there, I was really wondering, is it a condition that really for somebody to qualify to be awarded a PhD, he or she must publish? Then if it is yes, I thought maybe one of the papers should have not qualified me for this thing. Because the address you put there is Jambo University. The address there is Jambo University.
Affiliation.
But you are actually supposed to put that one. Affiliation number 2. The first affiliation should have been Makerere University, because you are a student of Makerere University, and the condition for you to qualify to be awarded a PhD is that you must publish. And the other NZALA from Jambo should have been somebody else. So why should we, I think that was an oversight. And I think if there is any other PhD student who is here, I think we should not be excited by the other affiliations in these publications. Once that we Makerere, then you will put those other affiliations, including the churches you belong to and what have you. So, I think, well, then the other thing is probably most of the figures, if they are not drawn by you, they should have a reference. Because you cannot just use, I noted some few as you presented there. I doubted whether you were the one who drew those figures. So check that the figures that you have used and all, adapted from some other sources are referred to.
Chair, as I promised, Amen.
Thank you very much, Dr. Ruru. So, please.
Thank you, Chair, and thank you, Nicholas, for developing this model. Out of experience, the stage where you are now in this presentation or in this Bible is more like where the time is the Lord. You've been running a topic, but whether you understand it or not, this is the time to realize whether you understand it. And now you can tell what maybe was less, and maybe what you need to add. And every day you can tell whether the bag is half full, quarter full, or full. So I also want to make my contribution on two perspectives I'm actually doing on where the discussion of the day stopped. That your work needs a reorganization and then also fine-tuning certain details. Now, I am basically saying there are two parts. One, to check whether you are knowledgeable in your writing. What you are writing, is it credible? And then the other is to check on your reporting. You have results. Are you reporting in a scientific way? Or are you under-reporting? Or you are reporting, exaggerating in some areas? So mine will address those two parts. But first, my background is I'm also a meteorologist by training. So I have a postgraduate diploma in meteorology. So when you say meteorological parameters, I see that I have a chance to enrich your work. I also saw you talk about solar radiation, although it's not in the title. And you talked with passion. Again, that's also my area. I did MSc. And actually, our discussion of the day was my advisor. So I think I can also make an input from that perspective. I wanted to begin with by looking at slide number 1, if it's possible. impossible to run it. It's impossible. Maybe I can try. I can make this first possible remark. I noticed that you are studying immediately. You need to have some background on meteorology and then also solar radiation, in addition to the other physics, computer science. And as a result, it has made an impact on the way you have presented your results, and even almost excluded discussion. You just run the reviews of values, but there's no explanation of why they do the way they do. In other words, you have used statistical analysis to come up with RMSE values, but you don't tell us what really they imply. Is the model of estimating? Is it underestimating? Is it possible to use it in the location of this nature? Is it kind of a location? Also, it has affected in the scope. You seem to have tagged your research findings to only benefit weather prediction. But under significance, you again mentioned in the research institution and so on. And consequently, it has spoiled your formation of the problem statement. So I will come back to that. And then the last one, as I said, is just an overview, is the fact that what you are presenting here is like news, and this is the news headline. Now, when you begin reading the news, at the end of it all, there is no news in it. But in this discussion now, the news has come out. That you have a model, for example, if it's a rainy day or it's cloudy, it's not the best model, leave it. But that news has not come out. You have only just given us statements, RMSE was this and so on. So it has gone unmeasured. So that's about your writing, rather your reporting. Is it really scientific? Is it complete? Is it incomplete? So that you write well. So from slide 1, you want to respond?
Yes, Doctor. That particular aspect of the model not being shown from cloudy days, well captured in the book.
I am saying in the conclusions, not even the recommendation that you say that deploy this model outside what? You see, the way you are reporting, it has to be sharp, okay? Don't just leave it in generalities. For us who have not worked with you during this research, we have no idea, but if you extract for us those lines, we go for them, okay? So I want to address myself first to the title. In that title, you note one thing is missing, although you discussed it extensively, solar radiation. It's not there. But you notice from your discussion, it really formed the heart of it. And then 2, the choice of language. You are saying meteorological parameters. How many do you know? How many are they? The major ones are 7. So you talk about sunshine hours, you have handled here, relative humidity, you talk about temperature, okay? And I think that's where you stop. But there is precipitation where rainfall falls under. There is pressure. There is cloud cover. There is wind. So let me illustrate it this way. If a human being is supposed to have the head, the hands, the upper part of the body, and then the limbs, and you present a person who has one limb missing, you are likely to use a different term. That's a lame human being also. Now here you are saying meteorological parameters, but you are not handling all of them. You are only stopping at sunshine hours, relative humidity, and then what? Temperature. So maybe to take a reading of selected what? So you have to use the proper language. So I was talking about your reporting. Is it really, the way you are writing something, is it credible? Does it bring out the meaning? And then the last thing on the title is this relative humidity, these sunshine hours. If you take midday here in Kampala and take also the same midday in Morocco, they will not have the same sunshine hours. So it is key where these medical parameters where do we locate it? Mombasa. You are predicting medical parameters for where? Okay? So I'm just showing you, at you these questions, not necessarily to dilute your work, to make you understand that what you are writing, does it make sense? Do you appreciate? Is it sharp? So that you can sharpen it accordingly. Then the next bit is this. I will treat your title as a news headline. That news flash, developing inverse artificial neural network algorithm. That's just one item for retrieval of level parameters. But see the way you write. You basically avoid the subject, the topic. You go to the next slide and see where you start from. The next one. You start from solar radiation. Go to the next one also, so that you realize it. Solar radiation. Go to the next one. Okay? Now, it is in that one that you try to mention about a model. And I think the last one, and largely used in forward model to obtain blah blah. Okay? And after that slide, I don't know what comes next. You proceed away from that slide. Imagine. So you go back that slide. So do you now notice that your title has artificial neural networks? You never mention what it is to us. We have not come from the same field of science. But you just leave it hanging there. You mention meteorological parameters, you don't mention to us what they are and which ones you are handling. So it leaves me thinking maybe your meteorological parameters, some of them include a hole, okay, a slasher, and so on. So in your reporting, you should try to be targeted and avoid being carried away by solar radiation. Is exciting to write about. There's a lot of literature, and I don't think I've written all. So I'm just saying, you go back and write within what your title captures. Okay? That will enrich your writing and reporting. The other is now to address your problem. You got the problem statement. I thought this would be your problem. Going by your responses to the questions asked here. In this case, it reads like the problem is lack of measuring instruments to provide the data, correct? Yes. But in your last statement of the background, you argue that studies have been done to develop prediction models. And those studies are basically forward. Alright? And now what you're now providing is what is missing. Which is what? Backward. And this is what you are doing. But you have run away again to equipment. Those people also started their study arguing that there is no equipment. Now, the first person who started with that, the second researcher now, should dig into where the previous one stopped. So I thought your problem here is that there is no model for reverse, for the inverse. And you are given a justification that it takes fewer what? Parameters. Yeah, so that is how good your problem would look like. And you throw away this. Now, this type of measuring instruments has also led you to slippery sides. One of it is you've tried to tag it to, the last sentence there, the discussant applauded you for that statement. But I have a problem with it. What are you doing here? You're providing for me data for solar sunshine, hours, data for relative humidity, data for temperature. Who needs it? It's not you to fix. You go to your significance. You have spoken about the people who need it. Okay, you have mentioned them, they are not so. Then, how did you get lost to tie your model to weather prediction? Because weather prediction is another world altogether. So you should have just stopped at saying, I'm providing data for this system of the potential users and so on and so on. And if that's the case, page 63, that discussion pointed out that we make an attempt on weather prediction. You are misled. Get it. Just throw it away. Because it's not even provided for in the literature review. It's even not provided in the conclusion. And that's not even weather prediction. You have just tried to play around. Okay? So it will just throw it away. If you reconstruct your problem certain being to get an inverse model for reasons you know, then significance will highlight that the beneficiary, the least. Okay? And then you don't get tied to weather prediction. Because your model is not actually it's not directly supported. Okay? If you're a student, I pay your school fees, I don't handle feeding, somebody else is handling feeding, your accommodation and so on. Do I now claim that I am the one providing for you wholly? Okay, you have to be careful. Alright? You have to acknowledge your minimal support. Alright? So that's what I ask you to do there, that avoid tagging this to weather prediction. But I acknowledge weather prediction as one of the beneficiaries where that data can be picked. And also others like research station and so forth. Even tourism needs sunshine hour data. Okay? For basking, to get vitamin D and so on, where more hours of sunshine. Sample come from very cold countries. They look at that data. And so it is useful on that note. So, just as an extension, the way you are writing, stick to your title and don't get carried away by material that is you have passion about, like solar radiation. Go back to your literature review and see how you can get rid of the solar radiation. And write, speak about artificial neural networks, how they work. Because you have given us this, but it's not there in the title. You should know in your literature review, talk about the artificial neural networks. Okay? How they are used to determine this and that, how they use it for universe and so on. So that you move away this, it's bulky and just pushed away the material that is important. So I thought you'd improve your literature review by getting rid of that.
Since is applying the top of physics, is that some degree of necessary?
I'm thinking, if you follow literature review, the discussion on artificial neural networks, previous works done, is not there. It's not there. And what is occupied that space is this basic knowledge, which we can find in textbooks. That's the way I'm arguing. I thought you could write clearly what's the research done before, to the extent that it brings out that they only stopped at forward. So now you need to bring in the reverse, and then also in addition, how do you do each of those objectives, write about them. How do you do the forward prediction? How do you do the other sector? That is the third objective. That's the way I'm thinking. But your devices with you, you will handle that. Okay. I think now I can add this. I have handled problem statement. You go to objectives, just to have a bit correct. The way you write objectives. Just so that you report in a correct way, in a sharp way. Look at objective 2. You are developing an algorithm that will retrieve 2 parameters. Why are you quiet about those 2 parameters? I already warned you about the usage of the terminology meteorological what? Parameters. Why don't you mention them? To retrieve, say, relative humidity and what?
I mentioned them, doctor, at the time of the methodology and also at the time of the results.
What I'm saying is that, which is the better way to present it? You, at this level, you now know what you're doing. Why don't you move the word measurable parameters and list them? Relative humidity, and then what? Temperature. So that's straightforward, like you did it for number 1. Okay? The same thing with the last one. Talks about 3 measurable parameters. Again, that's a title. Why don't you list them? Just move measurable parameters and just list them. So it is straight, it is sharp, okay? Because I cannot carry on with just general statements and wait up to the end. You try to unpack your work early enough, okay? And then the other problem is the objective 1. Do you know, do you have a background in solar radiation measurement? Do you have a background in global solar radiation measurement? It looks like that objective has no place there. This is my argument. You go to your book, I read through on page 37, and I ask you to read a statement. Because from the objective you are saying, I'm going to look for global horizontal solar radiation data and use it to predict sunshine data. But do you know how sunshine data is generated? It first measures global. And you read for me that statement. Read the first sentence.
On page
37, yeah.
yes, it says this sunshine measuring sensor.
Continue.
That was used to measure sunshine. Our values consist of 3 detectors: D1,
Yes.
D2, and D3.
Full stop. Now the next sentence is important.
Detector D1 receives and measures global solar radiation.
Full stop. You get it? That's how it measures sunshine. So it first measures global solar radiation and checks the size. If it's exceeding 120 watts per meter square, so meaning, let's say it's midday sharp, and the next second, there's radiation arriving, it takes the global solar radiation measurement, and if the amount is equal to the threshold of 120 watts per meter square, it records that as a sunshine second. If the next second the radiation it just measured again global is less, it doesn't record it. And keeps doing it for the whole 1 hour, then adds those seconds, how many hours they make. That's what you call the sunshine hour. And you do it for the rest of the day. Now here you are saying, also this radiation measured, solar radiation is also measured per second. In that second, how much solar radiation came? Even if it was beyond 120 or less, how much? So you also get that average at the end of the 1 hour, use it to predict the sunshine in that same 1 hour. Is it going to make sense? It's not going to make sense. So that's why I was asking you, are you knowledgeable in what you want? Do you?
Doctor, the one of the systems and radiation sensor, whereas it assesses the measure of the global solar radiation, never records it and it uses it in the process to calculate using the detector. And it is the direct solar radiation for which it makes the judgment of whether the direct solar radiation, which is 120 watts per meter square, or not, to record it as sunshine radiation second.
So my question was, if you are aware, it first takes reading of the radiation, record the sunshine hours. Okay? And the data you're using for the radiation is what? Is it average over 1 hour or average over 1 day?
It is average over 1 day.
And now the sunshine hours you're also predicting are those total all seconds of that day. So what I mean is it's also for that day, average sunshine hours of that day. Yes. So the question I was basically asking is, does it make sense in terms of the reliability of that prediction? I mean, you are using me to, I don't know how to explain it, but anyway, my comment is just that the machine first measures solar radiation and then gives whether there's a reading of sunshine hour or not. Then again you say here, I'm developing the prediction model. So in other words, one part is it is guaranteed that if you know the trend of solar radiation, then you know the trend of sunshine hours. There's already a relationship granted. That's my argument. You can think about it. As I said, this is a time to interrogate whether you miss some information about your research, whether you need to have it or not. Okay. Then I move to results presentation. I noted that there is no discussion on your results. You did well to come up with the analysis. You have the root mean square and so on. But whatever they mean you don't know, you don't speak about it. So as a scientific way of reporting, that is it. You have to come out and say, if for example, let us look at table, we go to table, one of the table of results.
Let's just focus. Makes a comment that you get it.
Okay.
And
you can even just stop there. You can even just stop there. If you look at the column of root mean square values, do you know what they mean? Do you know the range which you are looking for? You wanted in which range? That's what the model has given you, but wanted in which range? The acceptable one is what? 0 to what? Yes, small, but what's the size? 0 to what?
Root mean square errors.
Yes.
Vary the quality, vary according to the range.
I'm asking about the range which is acceptable. For example, I know it is 0.2 to 0.5. Then you can say that model has a fairly better accuracy. But in your case, they look at them. Somewhere you have 1, somewhere 0.7, and in some tables you can have, I think, 6, 8. So you need to focus on the acceptable range and then it helps you interpret that data. That's what I'm saying.
Yes, doctor. But what the mean square is not, how would I call it? It's not a unitless. And therefore, it's dependent on the units and the values range within. One to have a relative mean square of 1.6 for good performance, because the other ranges are high in enter. For example, what is square mean square of the values which has value values. Compared to
Maybe you just need to note it.
It's okay. My argument is based on check the formula you're using, because I'm arguing that there's a range for the formula you're using. It could be that that's a different formula, but you're not using it. And yet you're using an interpretation of another formula that you're not using. I have already pointed out, if you go to your conclusions, the conclusions are not sharp. Why? They are not sharp because in each of the objectives, you finish log the conclusion. Even when you come here as a student, your conclusion that you finish here is a certificate. That will tell whoever sponsored you is how you fare. But all you have is just results. This physics happened to go this, but there is nothing. So you need a conclusion of which was highlighted, I think, earlier also by the discussor. Those conclusions are the ones that input on the final what? Chapter 5 of conclusions. Okay? And I think the recommendations is the other last item is I will split with you that you should also be able to tell us that this model is suitable for this area. For example, you mentioned, and avoid using when it's on a cloudy day or what? Say rainy what? Day. So that should come out in your recommendation. That this model may be deployed, this one may not be very good. Okay? That's the news we want. I end there for now.
Thank you very much. Yes, that has been prolonged, but as you're aware, we need to maintain the quality of our outputs here. So we cannot cut short some of these issues. So when there are issues in place, we will address them. So let's move on to the public, please. Any comments in the line start with? I know we are tired and exhausted, but it's an examination process, and we need to go through the process. Yes, sir.
Thank you. My name is Katongo Daniel, and I'm a PhD student.
That's great.
Now, I also wish to appreciate Mr. NZALA for the wonderful work done. We have weaknesses, but yes, the work is wonderful. The way it's presented. But my question is, when I looked at your data scope, you collected it from two stations. You collected it from the Department of Physics and down there in the Meteorological station of the university. When you look at the separation distance with regard to the whole county, these 2 points may be looked at as one. Now, if the model you are developing is to predict these other parameters, when the input parameter is below the radiation, it's only going to work for a point in Makerere classic. In other words, Uganda National Meteorological Authority, through the term Trans-Africa Hydrometeorology, have about 56 weather stations with the Patmos Boardroom sensors. And those sensors measure all the parameters. Doctor was mentioning 7 of them, but Patmos Boardroom has 9, all of them. And data is available since 2016 up to now. If you want it at minute intervals, you get it. 5-minute intervals, you get it. 10-minute intervals, you get it. It's already stored. So my question is, why did we use all the data from Makerere universities and maybe don't sample from different stations spread across the country? When I looked at work which was done by Muyo and Banda, 2008, at least they used 4 stations. Why did you use only one for marketing customer? That's my question.
The data in this research, using only data from
Marketing.
yes. In this research, we were trying to look at a way of getting data, meteorological parameters, in a cheap way. Some of the data you tell us about is downloaded and measured by satellites. Even satellites may not be as accurate as the data looks.
Yes, it's actually ground
Yes.
It's ground measured data. The sensor is installed about 3 to maybe 2 to 4 meters.
All the 56 weather stations, and they are all working off to the way with pyranometers.
Yes.
I see a big sunshine sensor. Because personally, I went to Boardroom, I went to Retrieval, and I saw data gaps. Actually, International Meteorological Authority also showed that data. So, I found it easy and relevant to use data at this market level for all those meteorological parameters because it was available and looked of good quality. This research has also been reported about the quality of some of the data in some of those stations, where NZALA and another researcher here in Uganda reported Duamola of the technical people there, where at times the quality may not be good enough. I'm not discrediting, but we found this data from Makerere University of quality because the level of the technicians involved was sound. That's why we do it.
My question was on the spatial distribution.
So I think we'll discuss that as a part of
Yeah.
the presentation.
Exactly.
Yeah, that's not yes, Mr. PhD.
Thank you. Belon Fred Tunamasko. I've been a cameraman, but now I want to ask. First, I want to thank NZALA. Today, he kept time in presentation, and he finished when we all were ready to see him finish his presentation. I thank you for that. But on the same issue of, if you remember, my concern of sunshine duration hours, you still need to have that relationship between the two. If I don't have the sun, what is the nature of the rainfall? And if I have the rainfall, what is the nature of the sunshine duration hours? And how are the two affecting each other? I don't know whether I'm understood. Because when it is raining or cloudy, your sunshine duration hours are very low.
Yes.
Now, the same thing, when you have a lot of sunshine, that means your rainfall is not there. But then you are saying the solar radiation is the cause of the rainfall, because of perspiration from plants and evaporation from the water bodies, or whichever other evaporation takes place. So, which one facilitates the other easily? Is it the if I had a long sunshine duration hours, should I expect rain? Because now I expect to have had a lot of evaporation taking place. Now, if I have a cloudy day, does that mean exactly I had a very minimal sunshine duration hour? So you need, this is for your future understanding when you are explaining your work. How do the two interplay with each other and be able to, and that's where the physics, mainly why they were asking you the physics in relation to the computer science PhD, that if sunshine duration hours are affecting the rainfall, their duration means what the rainfall. Thank you.
It's not a it's a comment.
It's a comment.
It's a comment. It's a comment. Yes, yes, please, yes, sir.
Thank you, Chair, and thank you, panelists. Thank you, Mr. NZALA, for the presentation. Yes, you are eloquent, and clear. But comments have been made. When we present and people comment, it helps us improve the work. So, here, you and I asked your supervisors, I don't know them, to work with them to address the comments, and that work will come out because me, I'm Makerere University, Masters, PhD, work, so I have a high attachment to Makerere, and I know they want good quality work. And what they have been doing is trying to panel beat. You want to bring in this, and the comments, the way I listened, they can be handled. They are not beyond what? Addressing. So that is my view. Thank you very much.
Thank you very much, sir. Yes, please. Welcome back.
Thank you so much, members. I'm Wamoyo Faru. I'm a master's student in computer science, Makerere University here. It is so happened that I'm so much interested in Mr. NZALA's topic. Reason being is currently the topic that I handle. I was predicting travel, passenger travel for an airline. However, my concern and what I would want to advise NZALA is he has brought out the work very well. The fact that most of the items that are used concerning the artificial neural network are left out. And what I would urge him is, as earlier advised by most of the panelists, how do you incorporate the artificial neural network technique within the physics aspect? Because artificial neural network has its own, what I could say, a framework. It involves many steps. And one of the steps that he had talked about was measuring the forward pass. But you need now to explain how to bring in the solar radiations with issues concerning loss computation. You talked about the bias. How do you correlate the bias? Because the bias goes with the loss function. And here with the loss function, we try now to predict, try to see how can we train our model. That at time t, when you have what you talked about as the gradient descent, you are now iterating back in a backward model. So now there a question comes in where one of the panelists was now emphasizing. He couldn't get your model whereby you have, at the end you have an output, then as you try to do a reverse iteration of the output, again there is that, how the weights that are so many. So you need to try to move out and try to see how do you correlate the stochastic gradient descent with the work, because that one for it involves in updating the neural networks parameters, and you have talked about the epochs. Then, besides that, maybe you need to correct me very well if there are other activation functions that are in the physics perception that are different from the real activation functions that are used in the AN. I can give you an example. The AN has almost like 4 activation functions. Talk about the hyperbolic tangent function, the linear function, the rectified linear unit, then the sigmoid function, I didn't hear about that. Maybe in physics perception of the AN, there are other functions that are brought about. You need to look out on that because the AN technique is purely computer science perception, but how do you integrate it in physics and come out with that analogy that you are trying to relate on? Because each function deals with the kind of data that you are applying. Because you can apply, let's say, give you an example of the softmax activation function. That one deals with multi-class predictions. If you're talking about the rectified linear function, our activation function, it has a series of data. Because at the end of the day, in our AN, we are looking out of how do we correlate with the non-linearity of data. I mean, if the data was linear, the AN would just be working with the matrix formula. You just multiply and you have your weights, and at the end of the day, you have your activation. So those are majorly my concerns, that you try to correlate, see a way how you can apply the AN that is known out. And I saw one of the panelists was saying, what evidence or what proof can you give us not to give you a PhD in computer science? And that is basically what we are looking out. Otherwise, thank you so much for the good work done, and we look forward for the best.
Thank you very much. So basically, customize the usage of AN to satisfy your local requirements, so that we don't have to struggle to see the relationship. Any more comments? No online, please. Any comments? Thank you for sticking with us. Maybe not. I don't see any hands or anything. Okay, so I think since there are no comments, I will request that the public excuses us for about 5 to 10 minutes, so that we can deliberate over this presentation before we make a final verdict. Thank you. We'll do the same with the public online. We shall go off to deliberate for 5 to 10 minutes before you can join us. Thank you very much for sticking with us for this long. We very much appreciate in the last part of this process, and the committee had extensive deliberations here over the presentation that was made here today, and awarded an average mark of 68%. So I want to congratulate Mr. NZALA for getting this far. Congratulations. Well done. Now, this one is not done by any means. We have comments from 3 examiners. So we have 3 examiners who have their comments. Today we have raised several comments here, which need to be addressed. So we're going to generate a compliance report. Comment how we have responded to it, which pages and sections. Okay. Together with the comments I have forgotten of the discussant. So there are 5 sets of comments to respond to. Yeah, but the committee these comments can still be done in 3 months. So you can get them from the secretariat after the meeting and work on them. The compliance report together with the supervisors. Let them be happy that you have exhausted all of them before you submit the compliance report and the updated dissertation thesis to Dr. Lugu. Okay? So he's the one who's going to oversee the process of ensuring that we have been exhaustively addressed. And then he writes a letter to the dean recommend you for the award. So there's still work to do, so please, if you want to graduate to the next lot, yesterday when the ceremonies meeting is between 13th and 17th of January. So if you want to be in that lot, make sure your book is in the next 2 weeks or so. Earliest, otherwise you will not be in that book. But there's a lot of work still to be done, so please work on that. If you can, don't stress yourself. You can always graduate to the next year. At least you'll go through this big hurdle, which is the most important thing. So thank you very much. And if you have a comment or reaction from the public who have stuck with you all this long, you can do it now.
Thank you very much. I want to thank the panel, to thank the examiners, and to thank the administration for allowing me to move on and saying that I qualify to satisfy the requirements for the award subject to those conditions. Thank you very much. If they want to say you qualify. I'd like to acknowledge the support, guidance that I've got from very many people. I may not be able to mention all of them here now, but allow me to point out one category that has been so crucial, so critical in this process. And that is the team of my supervisors. I want to sincerely thank Professor Tadeo Senyon, Dr. Nicolaus Senyon, and Dr. Denison Munga. Can see we are coming towards the I want to thank very many of you, but I think I will not be able to mention because so many here, and those colleagues and friends online who have been following this presentation. Yes, they have been very true. But that is what new knowledge is. You must pass well receive. And I appreciate that you are patient with us. Yes. I want to thank one more person here, the discussant. Thank you very much. Thanks for the guidance. I will try to address the remarks. Thank you, everybody.
Okay, so thank you very much. I'll start by thanking the discussant, Dr. James Bro. Very much thank you. Been supporting us severally, and very much thank you for making time for us every time we call upon you, and it improves the work as you can see, which we are really grateful for. Thank the supervisors. It's a journey, long journey, and there are lots of issues, so we thank you for sticking with the student for this long and getting the student this far. And of course the support, whether it's funding from yourself or others, because without that, then the study cannot be completed. And then the examiners of the basis, as well as the examiners here today, we thank you for taking this time. It's taken quite long, but at least the due process has been followed, which is what we always strive for. Thank you so much for that. And the public, both here and online, thank you for sticking with us. And we call upon you every time new knowledge is disseminated here. As always, you always come and join us. Thank you so much, and thank the Secretariat and ICT team for always supporting this process. The Secretariat has supported this since the beginning and continue to support you until you complete and have the final book that has to be submitted. Thank you so much. The head of business is not here, but this is
here.
Yes, so normally the head tells us where the cake and party is. Yes. So I hand over the It's a job.
Yeah, it was really under oversight. I was sponsored by the German Academic Exchange Service. They are doing so good. They paid all my tuition. They gave me stipend to be able to move on this one. I'm grateful to the dad, the representatives here in Uganda, in Nairobi, and in Bonds, for giving me that opportunity to study this degree. Thank you, Dad.
And make sure you disseminate to them everything that you've been able to achieve here, because that helps to support our future candidates to know that we have knowledge and continue to appreciate their support. Thank you so much. So, good afternoon, ladies and gentlemen, and
Your next job. Hi sir. I'm still posing. I want God to give me life until after getting a pay. You want it? I want God to give me life until I'm okay. I'm going to do that. Make sure that you don't go before you sing. Otherwise, how are you?
Good to meet you. Hey, I'm fine. Today they were roasting me here. I think you're not there.
Yeah, yes. I want to talk to you after so that yeah, I'm going to put the camera here for... I'm also going there. But, I know.
Yes, be from around there. I can take this. You have to be part of this. Okay. The dean is not there. I'm taking this as many as possible. I must leave you.
NZALA. Congratulations.
Thank you.
From the department, please.
Thanks for your
This is the best. Now you go. Okay. This is the real thing now.
Auntie Barbara, tukuwa walifanani
Sala kugenda.